Hello everyone and welcome all to this course designed for exploring basics of C programming. In this course we will cover all about C programming language like installing text editor, using C compiler, how to write basic codes and many more things related to C. Basically there is a startup phase in every C programmer's life. In this phase he is a learner trying to understand the language elements and their use. At this stage, he wants a simple learning environment that helps him to learn or master the language. So before we dive into C programming, we need to learn a couple of things related to C. So let's start. Getting started with C. C is an example of programming language. We as a human being needs to communicate with computers, but computer understand the machine code or the language, that is a code stream like 10011001 and so on. Now, if we need to communicate to the computer using this code, then it's really complicated and error prone for human. Therefore, smart people created the programming language and we as a human learn programming language which is readable for human as well as understandable. So basically, we learn programming language and this is converted further into machine code that is understandable by the computer. Operating systems like Mac OS, Linux, Windows, Android, applications like Mozilla Firefox, Office, Chrome, Adobe, and games. These all are developed using some programming language. And C is one of the popular programming language that is used till now. Even this programming language is a base for other programming language as well. Now the instruction written in a file are known as source code. There is a compiler that compiles and convert this source code into machine code so that an output can be given in the form of executable program. Now executable program is a set of instructions that computer can understand. Other names for a program can be software or application. So all of this is fundamental of software or application development. All of these stuffs come under the subject called computer science. So basically computer science is dealing with all this coding stuff. Now let's discuss the things that are required to set up the environment for getting started with C programming. The very first thing that we need is operating system. So basically OS is divided into two types. One is Windows based, another one is Linux or Unix based. Now for Windows based operating system, we need to install a software that incorporates both the text editor as well as C compiler. CodeBlocks is one such fantastic application that can be used for developing a C program. And by compiling, you can execute the code at the same time. So this is the link from where you can download this application. For Unix or Linux based operating systems such as Ubuntu and Mac, both incorporates a well-known C compiler called GCC. This compiler is already installed in these operating systems, but if it is not there, you can install by simply writing the command as shown below. Sudo apt update, you can update the package, then sudo apt install build essential, sudo apt get install manages dev, and after this you can verify by writing GCC version. This will return you the latest version of GCC installed on your system. So the two important thing after the OS that is required for C programming is compiler. So as I already discussed, for Windows based we are using a code block and it contains MinGW, which stands for minimal GNU for Windows. Now GCC is a collection of GNU software. So CodeBlocks has GCC compiler, and for Unix and Linux based system, the GCC compiler is installed as essential package to manage development related to C. Next thing is text editor. Now for Windows, we can use Notepad, Notepad++ editor, but we will not require this editor because CodeBlocks has inbuilt text editor. For Unix and Linux based system, popular text editor are Vim or VI. Write our source code into it. Now for Windows, in order to download CodeBlocks, go to browser window and write CodeBlocks and hit enter. The very first section you will get CodeBlocks and just click on this. This is the platform for CodeBlocks. Click on this download section and you will be redirected to the download page. Click on this link, download the binary release. So here are the code block setup file. You can also find for Linux as well as Mac OS. If you don't want to use Vim or other editors in Linux or Mac, you can use code blocks in these OS also. So these are the setups for Linux based operating system and this is for Mac operating system. So just click on this code block 20.03 with MinGW setup. Click on the link to download and your downloading will be started. Once downloaded, just run the setup file, click on next, agree for the license agreement, click next and click on install. It will take some time to install, and once installed you can just click on finish. So we are ready to go with the programming. In the next session, we'll be writing the very first C code and compile and see the fascinating output of the code. That's all for this session. Hello and welcome back to this course. In the previous session, we have discussed the overview of C programming language. Now, in this session, we are going to discuss the basics of C language. Communicating with the computer involves speaking the language the computer understands, which immediately rule out English as the language of communicating with computer. However, there is a close analogy between learning English language and learning C language. Now, the classical method of learning English is to first learn the alphabets, then learn to combine these alphabets to form words, which in turn are combined to form the sentences, and sentences are combined to form paragraphs. Learning C is similar and easier. Instead of straight away learning how to write program, we must first know what alphabet, numbers and special symbols are used in C. Then how using them constant variables and keywords are constructed. And finally, how are these combined to form an instruction? Group of instructions would be combined later on to form a programs. There are 4 important aspects of any language, that is, the way it stores the data, the way it operates upon the data, how it accomplishes input and output, and how it lets you control the sequence of execution. Now let's talk about the C character set. Character denotes any alphabet, digit or special symbol used to represent information. The alphabets that are used in C language is the same that are used in English, that is from A to Z, both the capital and small letters. Digits, that is from 0 to 9. Special symbols that are available on our keyboard. Now these are combined to form constants. It's an entity that does not change. Variables, entity that may change. And finally keywords, which are the words whose meaning has already been explained to C compiler. Combining all these groups together are called tokens in C language. Now let's discuss the types of C constant. Basically, C constants can be divided into 2 major categories, that is primary constants and secondary constants. Primary constants involve integer constant, real constant, character constant, whereas secondary constants are array, pointer, structures, union, enum, etc. Now at this stage, we would restrict our discussion in only primary constant, namely integer, real and character constant. Integer constant. An integer is a number whose range depends upon the compiler. If compiler is of 16-bit, then the range is from -32768 to +32767. Now the rules for constructing an integer constant is, it must have at least one digit, it must not have a decimal point, it can be both positive and negative, number without sign is positive, commas or blanks are not allowed, range as defined by the compiler. Example, as you can see, 426 plus 782 minus 8000 minus 7605 and etc. Next is real constant. Real constants are often called floating point constant. These can be written in 2 forms, the fractional and exponential form. And the rules for constructing a constant, it must have at least one digit, it must have a decimal point, can be both positive and negative, and default sign is positive. Commas or blanks are not allowed. And if I talk about exponential form, then the range is defined from -3.2 e raised to the power 38 to +3.4 e raised to power 38. As an example, we can see +3 to 5.34, 426.0, -32.76, -48.5792. These are the fractional form representation. If I'm talking about exponential, then examples can be +3.2 e raised to the power -5, 4.e raised to the power 8, -0.2 e raised to the power 3, -3.2 a raised to the power -5. And the last one is character constant. Now a character constant is single alphabet, single digit or special symbol enclosed within a single inverted commas. Now inverted commas must be pointed to left for valid character constant. Maximum length of a character constant can be 1 character. Now as an example, you can see A enclosed with single inverted commas. Similarly, L, 5 and equal to sign. Next is variables. Now variables are the entity that may vary during program execution. This is the name given to location on memory. And the rules for constructing a variable is that name of variable is a combination of alphabets, digits or underscores. Maximum length of a variable name can be 247 characters. It is safe to stick to 31 character for simplicity. First character must be an alphabet or underscore. That means it should not start with digit. Again, commas or blank spaces are not allowed. Special symbols are not allowed except underscore. You can see the example: gross underscore salary, SI underscore int, M underscore HRA, pop underscore E underscore 89, etc. Now the variable names follow the same rules for both primary as well as secondary type. Finally, the keywords. Now keywords are the reserved word that have some specific meanings that is understandable by the compiler itself. So in the figure you can see there are 32 keywords available in C language, like auto, break, case, char, const, continue, default, do, double, else, enum, extern, float, for, go to, if, int, long, register, return, short, signed, size of, static, struct, switch, type def, union, unsigned, void, volatile, while. So that's all for this session. In the next session we are going to write our first C code. So let's start. Rules applicable to C program. Now before we begin with our first C program, do remember the following rules that are applicable to all C programs. Now each instruction in a C program is written as a separate statement. Therefore, a complete C program would comprise of series of statements. The statements in a program must appear in the same order in which we wish them to be executed, unless, of course, the logic of the problem demands a deliberate jump or transfer of control to a statement, which is out of sequence. Blank spaces may be inserted between two words to improve the readability of the statement. However, no blank spaces are allowed within a variable, constant, or keyword. All statements are entered in small case letters. C has no specific rules for the position at which a statement is to be written. That's why it is often called a free-form language. Every C statement must end with a semicolon. Thus, semicolon acts as a statement terminator. Let's now write down our first C program. It would simply calculate simple interest for a set of values representing principal, number of years, and rate of interest. I hope you remember the formula for calculating the simple interest. That is principal multiplied by number of years multiplied by rate of interest divided by 100. So we are going to write a very first C code to calculate the simple interest. Let's go. Create a folder on your desktop and name it as C programs. We will be storing our all C codes in this folder. Okay. I hope you have installed the code blocks. So this is the code block quick launch icon. Just open the code block. Okay, so this is the startup page of code block. If you see in the editor window of start here, there are various links like create a new project, open an existing project, visit the code block forum, and report a bug or request. Okay, now if you want to create a project, you can simply click on this link, but we are not going to create a project. We are simply creating a C code. So just go to file menu, click on new and empty file. Okay, so basically this is the editor window where we can write our code. So let's start writing the code. If you want, you can add comment by using /star. The very first thing is hash include. Just copy what I'm writing. I'll explain each and every statement that I have used in this code. stdio.h. Next is void main, small brackets open close, start the curly braces and close the curly braces. Hit enter. Now we will define a variable like int e for principal, n for time, semicolon for ending this statement. Next is float r comma si. Now r is for the rate of interest and si for simple interest. Now let's take a value for each variable. So p equal to 1000, n equal to 3 and r equal to 8.5. You can again write the comment formula for calculating simple interest. Next is the formula, that is SI equal to P multiplied by N multiplied by R and divided by 100. Okay, and at last we want to print the result. So print F within double quotes %F comma SI. Okay, so we are done with our code. Just go to file, click on save file, go to the desktop where you have created the folder C program, create a new folder and write first code. Okay, open the folder and rename this code like my first code. Don't forget to add .c extension. Okay, now click on save. Fine. Now let's discuss the components of this code one by one. So this is the code. The very first line is hash include stdio.h. Now it's a preprocessor command. That means before executing any code, there is some preprocessor command that instruct the processing unit to add some header files. Now stdio.h is a header files which includes the functions for standard input and output, and include is a keyword that will add this header file in our code. Next is function. Now here we have used a main function. Main is a collective name given to set of statements. Now this name has to be main. It cannot be anything else. All statements that belong to main are enclosed within a pair of braces. Now as you can see, the curly brackets to end within these curly braces, all the statements are written. This means that all these statements belong to this main function. So technically speaking, main is a function and every function has a pair of parentheses associated with it. Now what is function and what's its use, we will discuss in detail in upcoming session. So for now, just remember this is a function that includes some statements to be executed. Okay. Next is variables. So as I already discussed, the variables are the entity that may change during the execution of program. That means the value for P, N, R and SI can be changed during the program. So during the initialization there are nothing to store, but after that the variables P, N, R are having values like 1000, 3 and 8.5. Next is terminator. Now as I already said that any C statements always ends with a semicolon. Next is comments. Now comment should be enclosed within /*/. You can see the formula for simple interest has been enclosed within this. Anything written within /*// is treated as comments. Though comments are not necessary, but it's a good practice to begin a program with a comment indicating the purpose of the program, its author and the date on which the program was written. That means you can add the description of your code, day and date, like for your reference. Any number of comments can be written at any place in the program. Now this comment can be written anywhere in the code. You can write from the beginning, you can write in the end, or even within the statement and after the statement also. Next is operators. Now star and slash used in this formula, these are arithmetic operators which are available in C. That means that are used for doing arithmetic calculation. So in C, the arithmetic operators are plus, minus, multiplication and division. We'll discuss all types of operators in the upcoming session. And at last, printf, that is used for displaying output. Now printf is also a function which is used to display the data on the screen. Very first thing is enclosed in double quote %f. Now this %f or %d, %c are also there. These are called format specifier. What does this do is, this defines the type of the data to be printed. Like if you see the simple interest, it will give you the value in decimal points. Like it's not a complete integer, it will give you a result in point form. So F stands for float, that means floating point. So %f is a format specifier of float type, and SI is the variable that store the value of simple interest. So printf within the bracket %f comma SI will display the output. Okay, I hope the idea of this code is little bit clear. We'll discuss each and everything in details in the upcoming session. So just stay connected. Now next thing is compilation. Get back to the editor window. Now we have saved the code. Now you can go to build, click on build to compile the code. Okay, so here are lot of window and in which there is a build log. So if you click on this build log, you will see the message of compilation. So the process terminated with status 0 minutes 2 seconds. That means the code compiled within 2 seconds and having 0 errors, 0 warning. That means the code compiled successfully and there is no any errors. Once the code compiled successfully, you can go to the folder that we have created for the code and you will see there on compiling the program, its machine language equivalent is stored as an exe file. That is my first code.exe. So this is the executable application that is available after compilation, and this will be executed by the processor. Now if we copy this file to another machine, we can execute it there without being required to recompile it. In fact, the other machine did not even have a compiler to be able to execute the file. Click on this play button which is run. So if you click on this button, you will see an output window that will give you the value of SI, which is 255. We have successfully write our first C code and it compiled successfully, and after running this code it give you the result within no time. Similarly, in this course we will create a number of codes that will give you the fascinating output. Now let's come back to our discussion. Now in the program discussed, we assumed the value of P, N and R to be 1000, 3 and 8.5. So every time we run the program we would get the same value for simple interest. Now if you want to calculate simple interest for some other set of values, then we are required to make the relevant changes in the program and again compile and execute it. Thus the program is not general enough to calculate simple interest for any set of values without being required to make a change in the program. Moreover, if you distribute the exe file of this program to somebody, he would not even be able to make changes in the program. So the next thing we need to learn is how we can receive input from the user. So to make the program general, the program itself should ask the user to supply the value of P, N and R to the keyboard during execution. Now this can be achieved using a function called scanf. This function is a counterpart of printf function. Printf outputs the value to the screen, whereas scanf receives them from the keyboard. Now using this scanf, you can see the modification in the code. The first printf output the message that is enter values of P and R on the screen. Hence, we have not used any expression in printf, which means that using expression in printf is optional. We can simply display a message also. Note that the ampersand before the variable in the scanf function is a must, because ampersand is an address of operator. It gives the location number used by the variable in memory. When we say ampersand T, we are telling scanf at which memory location should it store the value supplied by the user from the keyboard. Detailed working of this operator will be discussed in future lectures. So now if you run this code, then what happens on executing this code, you will have to enter the value of P, N and R from the keyboard and it will calculate the SI. Okay, so now this is user friendly and you can calculate the simple interest for any set of values. So that's all for this session. In the next session we will be Hello and welcome back to this course. In the previous session, we have developed a C code in order to calculate the simple interest. And within the code, we have used multiple instructions. So in this session, we are going to discuss the types of instructions in C. So let's start. Instructions in C are broadly classified into three categories. The very first is type declaration instruction. Now these instructions are used to declare the type of variables used in a C program. Any variable used in the program must be declared before using it in any statement. Declaration statement is written at the beginning of the main function. If you see the example, int base, that means an integer value, float rs, salary. So rs and salary variables are of floating type. That means the decimal numbers. Char, name, code. Now these name and codes are of character data type. C offer various data types that will be discussed in this session. Next is arithmetic instruction. Now a C arithmetic instruction consists of a variable name on the left hand side of equal to and variable names and constant on the right hand side of equal to. The variables and constant appearing on the right hand side of equal to are connected by arithmetic operators like plus, minus, multiplication, division. Let's understand with an example. Int, add, float, kot, data, alpha. Now these are the variables and we have assigned a value. Add equal to 3200, kot equal to 0.0056. So data equal to add divided by kot plus 3.2 multiplied by 2 divided by 5. So this complete instruction is a type of arithmetic instruction. Last one is control instruction. Now as the name suggests, the control instructions enable us to specify the order in which the various instructions in a program will be executed by the computer. In other words, it determines the flow of control in a program. Basically, there are four types of control instruction in C. Number 1, sequence control. Number 2, selection or decision control. Number 3, repetition or loop control. And number 4, case control instruction. We'll be discussing these in details in future session. Now let's understand the computer number system. That means the number system that is used in digital computer. So basically there are four types of numbers that are used in computers. Very first is decimal number. We all are familiar with this decimal number because we use in our daily life. It contains 10 different symbols, that is from digit 0 to 9. Now there are 10 different symbols, that's why it is called as base 10 number. Each position represent a fixed power of 10. Now this fixed power are calculated as positive on the left of decimal point and negative on the right of decimal point. If you see the example, 14.75 is the decimal number and this has been represented using the positional value. So if you calculate this, we'll get 1 into 10, 4 into 1, 7 into 0.1, 5 into 0.01. And adding all this, we'll get the number that is 14.75. Next is binary numbers. Now this is the machine code that we have discussed in the overview session because machine understand only the language of 0 and 1. So binary number is the machine code that is understandable by the computer. Now it contains two different symbols, that is 0 and 1. Therefore it is called as base 2. Each position represents a fixed power of 2 and again on the left hand side of binary point the power is positive and right hand side it is negative. If you see in the example 10.11 which is a binary number is represented as positional value like 1 into 2 to the power 1 plus 0 into 2 to the power 0 plus 1 into 2 to the power minus 1 plus 1 into 2 to the power minus 2. Evaluating this whole result you will get 2.75 which is the decimal equivalent of this binary number. That means if I'm entering 2.75 through my keyboard, then this 2.75 will be converted into binary, that means 10.11 and then sent to the computer processor. Next is octal. Octal has 8 different symbols from 0 to 7. That's why it is also called as base 8 and here the position represents a fixed power of 8. Again same thing, on the left hand side of octal point the power is positive and on the right hand side it's negative. As an example 43.26 is an octal number and if you represent this in the form of positional number, then 4 cross 8 to the power 1, 3 into 8 to the power 0, 2 into 8 to the power minus 1, 6 into 8 to the power minus 2. Evaluating this will give you 35.34375 which is again the decimal equivalent of this octal number. And the last one is hexadecimal. Now hexadecimal is the most commonly used number system in embedded C or the programming of controllers. It contains 16 different symbols from digit 0 to 9 and after that the character A to F. That's why it is also called as base 16 and again the each position represent fixed power of 16. Now left hand side of the hexadecimal point is positive power and on the right it's negative power. As an example 7D.A4 is a hexadecimal value and representing this in the positional power system we will get 7 into 16 to the power 1 plus D into 16 to the power 0 plus A into 16 to the power minus 1 plus 4 into 16 to the power minus 2. Evaluating this we will get 131.265625 which is again the decimal equivalent of this 7D.A4 hexadecimal value. Once this number system is clear to you, now let's discuss the various data types offered in C. Basically there are 4 categories of data types. Very first is primitive. Primitive data types are char, int, long, float, double. Now if I talk about the range, then char is from minus 128 to plus 127. The value that has been represented in bracket is the value for unsigned char. That means if we ignore the positive and negative sign, then the range is from 0 to 255. Size is 1 byte and the format specifier is %C. Similarly, int, that is integer data type, its range is from minus 32768 to plus 32767 and for unsigned int it's 0 to 65535. Size of 2 byte represented by the format specifier %D. Next is long data type. Its range is minus 214748364 to plus 214748364 and for unsigned long 0 to 429496725. Size is 4 byte and represented by format specifier %LD. Next is float data type. Its range is minus 3.4 e raised to the power 38 to plus 3.4 e raised to the power 38, having size of 2 byte and represented by %F format specifier. The last one is double data type, range minus 1.7 e raised to the power 308 to 1.7 e raised to the power 308. It is having the size of 8 byte represented by %lf. After the primitive data type, we have derived data type. Within derived data types, we have array, which is a collection of similar data types in a list manner. Function, which is collection of statements and instruction. Pointer, the data types that hold the address of variables. Next is user defined data type, and we have enumerated, structure, union. Enumerated, that means the data types enumerated as different names as per user requirement. Structure, it is also a collection of data but of different data types. Union, similar like structure but difference in size in memory. And the last one is empty data type, that is void. Now void can be used within function and pointers. Now this data type doesn't hold any value. So if I talk about function returns as void, that means a function with no return value. If I talk about function argument as void, then a function with no parameter. And if it is pointers to void, then address of an object is considered instead of its data type. Now you must be thinking that how this range is calculated for primitive data types and what are this size 1 byte, 2 byte, 4 byte. So let's understand what does this mean. Let's discuss the signed and unsigned bit. So for that we need to understand the terminologies used in size. A single digit is called as bit. Group of 4 digit is called nibble. Similarly, group of 8 digit called as byte, and if it is 16 then it is called half word, and at last if it is 32 bits, that means 32 digits, then it is called a word. Okay, so whatever size has been given to the data types are measured as byte. Now if I talk about unsigned bit, so let's take a 1 byte data, that means 8 bits, and if we fill those 8 bits by 1, then the highest value that we will attain is 255. Now this value is calculated using the positional number of binary, that means 1 into 2 to the power 0, then 2 to the power 1, 2, 3, 4, 5, 6, 7, increasing from left to right. And similarly, if I replace by all zeros, then I got the result as 0. So if I talk about unsigned bit, then 1 byte is from 0 to 255. Similarly, if I talk about signed bit, then the MSB, that is the leftmost bit, is considered as signed bit, which is shaded as red in this section. So 0 represents the positive sign. Like if the MSB, that is most significant, is 0, then the rest value is calculated as is positive in nature. Similarly, if the MSB is 1, then 1 represents the negative sign. Okay, so if I take all ones considering the most significant as signed bit, then the value that I will get is minus 127. And if I replace all ones by 0, considering the signed bit for negative, we'll get minus 0. But if you see the signed bit, then there is two representation of 0. That means if I take this case, that means the positive 0. So this is the equivalent to 0. Similarly, this is also equivalent to 0 but in negative sign. So in the number system, 0 is neither treated as positive or negative. So we have to consider only one representation of 0, that means this. So what about this representation? So if you see this 0 representation in negative sign, then you will see it is the complement of this 127. Like if you see this value 1111111, then the equivalent is 127, and since it is 0, that's why it's positive. Okay, so now if you complement this, now you must be wondering what is complement. So let's discuss the ones and twos complement. Ones complement of a binary number is swapping of zeros by ones and vice versa. And similarly, twos complement of a binary number will be the ones complemented and adding 1 to it. Now this both ones and twos complement is used to represent negative binary numbers in digital systems. So if we take the complement of this positive 127, we will get this value. That means where 1 is present, we get a 0, and where 0 is present, we get 1. So this 127 gives you the minus 128, because if you calculate the decimal representation for this 8-bit value, then we'll get 128, but most significant bit is 1, so we get minus 128. Don't put so much stress on this. This is just a representation. We'll explore more when we will be going to use this thing in our code. So that's all for this session. Hello and welcome back to this course. In the previous session, we have discussed the types of instruction in C. For the type declaration instruction, we have discussed the data types and the number system associated with it. In this session, we are going to discuss the instruction that are used to perform some operations. That means operators in C. So let's start. Operators are the symbols that tell the compiler to perform specific mathematical or logical function. C language is rich in built-in operators and provide the following types of operators. The very first is arithmetic operators like plus, minus, multiplication, division, modulus, increment, decrement operator. Next is relational operators equal to, not equal to, greater than, less than, greater than equal to, and less than equal to. Next is logical operator, that means and, or, not. Bitwise operators, ANDing, ORing, XORing, complementing, left shift, right shift. Assignment operators equal to, plus equal to, minus equal to, multiplication equal to, division equal to, modulus equal to. Similarly, left shift equal to, right shift equal to, ANDing equal to, XORing equal to, ORing equal to. And the last one is miscellaneous operators, size of, ampersand, pointers, and conditional statement. Now let's discuss these operators one by one and understand with the help of examples. Arithmetic operators. Now arithmetic operators are used to perform mathematical operation. The following table shows all the arithmetic operators supported by the C language. Now assume variable A hold 10 and B holds 20. Then this is the table for the operators and the result. Like plus, so A plus B, that is 20 plus 10, 30. Minus, that means 10 minus 20 minus 10. Multiplication, 200. Division, 20 by 10, that is 2. Modulus, it returns the remainder after the division. Okay, so 20 divided by 10 will give you remainder 0. Increment operator, that means increase the integer value by 1. That means if I write A plus plus, then it is equal to 11. A minus minus, then it is 9. That is decrement operator. Next is relational operators. Relational operators are used to check the relation between two values provided. The following table shows all the relational operators supported by C. Now assume value A holds 10, B holds 20 again, and then use these operators and see the result. So A equal to B. It checks whether the two operands are equal or not. So if A and B are tested for equal, then it's not, because 10 is not equal to 20. So it's not true. Next is not equal to, then it will give you true answer. Greater than, then A is greater than B. Of course, it's not true because 10 is not greater than 20. Less than, A less than B is true because 10 is less than 20. Greater than equal to, again not true. Less than equal to, true. Next is logical operators. Logical operators are used to test the logic of two operands and gives a Boolean result. Now Boolean result is either true or false, just as we see in the previous session. In the previous operators, the following table shows all the logical operator supported by C language. Now assume the variable A hold 1 and variable B holds 0. Then A and B is false. That means 1 ending with 0 will give you 0, which is false. A or B, that means 1 or 0 will give you true. Next is not operator. So not of A and B is true. That means A and B is false and not operator will returns the negative of false, which is true. Now this and, or, and not operator is basically the gate, the logic gates that we have studied in physics. So for the logical operation performed by the gate, we have operators called logical operators. Next is bitwise operators. Bitwise operators are used to perform bit manipulation of operands. The following table lists the bitwise operators supported by C. Assume variable A holds 60 and B holds 13. Then the binary representation will be for 60 it is 00111100, and for 13 it's 00001101. Now the very first operator is binary AND operators. Binary AND operator copies a bit to the result if it exists in both operands. If you remember the truth table for AND gate, for input A and B, the output is 1 if both the input is 1. So if you see the same thing with this operator, like in A and B, wherever there is 1, the output is 1. If any of the operand is 0, then output is 0. Therefore, it is equal to 12. Similarly, there is binary OR operator, which copies a bit if it exists in either operand. That means the truth table for OR gate. For input A and B, the output will be high if any of the input is high. So again check in A and B, wherever there is 1, just copy. So 1, 0, 1, 1, 1, 1, 0, 0. So it will give you 00111101, which is 61. Next is binary XOR operator. So it copies the bit if it is set in one operand but not both. So basically XOR operator is if the operands is not same, then answer is true or answer is 1. If you remember the XOR gate truth table, then for input A and B, Y will be high if the operands are not equal. That means if you see for A and B, if it is 0 and 1, then output will be high. If it is both 0, then output low. If it is both 1, again output low. Again both 1, again output low. If it is 1 0, so 1 1 0, again 1, and 0 0 for these two conditions. So we'll get the output 0 0 1 1 0 0 1, okay, which is equivalent to 49. Next is binary ones complement operator. So it is unary, that means it only needs a single operand. You can complement of A or B, but not both in one statement. So if complementing A, that means replacing all ones in A by 0, we'll get 1 1 0 0 0 0 1 1. Next is binary left shift operator. This operand value is moved left by the number of bits specified by the right operand. Like if I am writing A left shift 2, that means this value is shifted towards left by 2 bit. So these 0 0 will be shift to left, discarded, and we will get 1 1 1 1 0 0 0 0, which is this the value. Similarly for right shift operator, A right shift 2 will give you 15. That means this bit will be shifted towards right. This 0 0 will be discarded and it become 0 0 0 0 1 1 1, which is 15. You can try various values and test the result of these operators in code blocks. Next is assignment operators. Now assignment operators are used to perform some arithmetic operation and assign the resultant value to a variable. The following table shows all the assignment operators supported by C language. Here again, let's take the value of A 10 and B 20. So equal to, so C equal to A plus B, that means A plus B is the addition operation and the value is assigned to C. Plus equal to means C plus equal to A, that means C equal to C plus A. Add and assignment operator. So it adds the right operand to the left operand and assign the result to the left operand. That means if I'm writing C plus equal to A, then A is added to C and the value is assigned to C itself. Similarly, for subtract operation, it's C minus equal to A, that means C equal to C minus A. Similarly for equal to, division, modulus, left shift, right shift, ANDing, ORing, and XORing. Okay, so whatever bitwise operators we have, we can use with the assignment operators also. Next is miscellaneous operators. In C, there are 4 miscellaneous operators. First is size of. This is the function that returns the size of a variable. Let's take an example. We have defined a variable int A, and if we calculate size of A, which is an integer, that is 4 byte. Next is ampersand. It returns the address of a variable. Like if I'm writing ampersand of A, then it will returns the address of location where variable A is stored in the memory. Next is pointer to a variable. Example, pointer A then points the value stored at the location address stored by the pointer variable A. And the last one is conditional expression. It is a short form of if-else condition. Let's understood with an example, that is A is greater than B, question mark A colon B. This statement means that check if A is greater than B. If it is true, then returns A, otherwise returns B. Now what is if-else condition? We'll discuss it later on. We have discussed multiple operators in C. Now what happens if lots of operators are connected in a single statement? What will be the order of execution and how the processor will operate with all these operators? So for that we have operator precedence in C. For mathematical, we are familiar with the BODMAS rule. That means the bracket of division, multiplication, addition, subtraction. That means the priority of performing a mathematical operation. Similarly, in C, there is operator precedence and we have 2 operator precedence. One is right to left and left to right. So these are the unary operators, that means which needs a single operand. So right to left precedence, that means if these are used in a statement, then it will be executed from right to left. So size of will be of higher priority, then ampersand, then pointer, then minus minus, then plus plus, complement, not, minus, plus. Similarly, conditional, then assignment. So all these operators will be operated with right to left precedence. That means the rightmost will be of high priority. This is the example for left to right precedence. Like if these are the operators used, then the leftmost will be preferred first. That's all for this session. Hello and welcome back to this course. In the previous session, we have discussed about the operators and its types. Now in this session, we are going to discuss about the decision control structures. So let's start. We all need to alter our action in the face of changing circumstances. Like if the weather is fine, then I'll go for a stroll. If the highway is busy, I would take a diversion. If C says no, I would look elsewhere. If the pitch takes spin, we would win the match, and so on. Now by default, the instruction in a program are executed sequentially, right? We don't have to do anything. In serious programming situation, seldom do we want the instructions to be executed sequentially. Many a times we want a set of instructions to be executed in one situation and an entirely different set of instruction to be executed in another situation. This kind of situation is dealt in C programming using a decision control instruction. Now a decision control instructions can be implemented in C using if statement, if else statement, and conditional operators. Now how these are used, we'll discuss in this session. So let's start with if statement. This is the syntax: if and a condition enclosed in a parenthesis that will be an expression that evaluates to true or false. Depending upon the output of this condition, these statements can be executed. So in this condition, if the statement returns true, then this particular branch of code will be executed as indicated by green color. Okay, that is true branch, and this is executed if the condition is true. The keyword if tells the compiler that what if follows is a decision control instruction, and the condition followed by the keyword if is always enclosed within a pair of parentheses. If the condition, whatever it is true, then the statement is executed. If this condition false, then the program skips this statement and jump to following statement. So we express a condition using C's relational operators, and the relational operators allow us to compare two values to see whether they are equal to each other, whether one is greater than the other. That means these condition expressions can be a relational one or any comparison that will evaluate to a true or false value. Okay, so we have discussed a lot of operators in C. So whatever the suitable operators can be used for conditional expression can be used here. Now let's take an example. We have to print a statement based on the test expression. Okay, so this is a demonstration code. We need to read a number from a user, okay, and we need to check whether this number is less than equal to 10 or not. We have printed a message like enter a number less than 10, and we have read the values from the input window by scanf. Okay, and after that there is a if condition. So if num is less than equal to 10, so this is a relational operator that we are comparing whether the number is less than or equal to 10. So if this condition is true, that means if the number is less than or equal to 10, we will print the message, what an obedient servant you are. That means we have asked the user to enter the number less than 10 and they have done exactly the same. Now if you want to understand with the block diagram, then this is the equivalent block diagram for this code. The code start, print, enter a number less than 10. That means this is the first execution for printf. Then input number, and then it is checked that number less than or equal to 10. Okay, so if it is yes, then we have to print what an obedient servant you are. Okay, now let's implement the same code using the code block. Let's move to the code block. Okay, so just go to file, new, empty file. Okay, and just save it to the location that we have created the folder on the desktop. Okay, so don't forget to create new folder for each and every program that we write. Okay, so create a new folder, write if statement. Okay, open this folder and just save here for the C file. Okay, so I have written if underscore dot C. Okay, now click on save. So we have successfully saved this C file. Now we can write our code. So you can add comments like demonstration for if statement. The very first thing is we have to include the header file. So hash include standard input output dot stdio.h. So we have added the header files. Now we have to go for void main. Okay, created the main function. Next thing is we need to define the variable. Let's say int num. Okay, we have to print the message. So printf within inverted commas we have to enter the message. So enter the number less than the message on the next. We have to read. So reading the input value from the user. Okay, I hope it's visible to you, or let me just zoom it for more clear visibility. Okay, so reading the input value from the user. So for that we have scanf. So what type of number we are getting is integer type. So %d, that is format specifier. Next is the number we have to store in this variable. So %num. Okay, now we have done. We have printed the message. We have read the value. Now we need to compare. So again write the comments that testing the numbers. Okay, so for that we'll write if condition num less than equal to, this is the relational operator that we are comparing the number that we have read from the user, which is less than or equal to 10 or not. So if it is less than or equal to 10, we'll print the message, what an obedient servant you are. Okay, so that's it for the code. Okay, now just build the code and you will see in the build log that there are 0 errors and 0 warnings. Okay, so you can directly run from this icon. Okay, so click on run. Now enter the number less than 10. So I'm entering 6. Then I have got this output because 6 is less than 10. Okay, now let's run once again and enter the value 12. You will get no output. Okay, that means the condition is not satisfied. That is, this number 12 is not less than equal to 10. Therefore we don't get any output message. Okay, so I hope concept is clear. If statement is very frequently used in programming. Fine, so that's it for this session. In the next session we'll discuss the if else statement. Hello and welcome back to the course again. So we were discussing about the decision control structures, and in the previous session we have discussed about the if statement. Okay, so in this session we are going to discuss about the next statement, which is if else statement. So this is the syntax for if else statement. So we have seen there will be an if keywords followed by a conditional expression, and if that returns true, that certain statement will be executed. But if this condition false, then what happens next? So for that we have a else clause in this if else statement. Okay, that means in the previous session we have discussed only the if part, and now we have another block which is called else. So this is the block that will be executed when this condition will be false. So this is shown as false branch. Okay, so the if statement by itself will execute a single statement, right, or a group of statements when the expression following if evaluates to true. It does nothing when the expression evaluates to false, that we have seen in the previous code. Okay, so we can execute one group of statement if the expression evaluates to true, and another group of statements if the expression evaluates to false. Fine, so this is what is the purpose of this else statement that is explained right now. Okay, let's take an example. So this is the flow diagram of the code, that the code will start, then input will be the basic salary, and that will be compared that whether this basic salary is less than 1500 or not. Okay, so if it is less than, then the HRA will be the basic salary multiplied by 10 divided by 100, and next the calculation part occurs for printing the gross salary. Okay, now if it is not less than 1500, then we have the HRA 500, and as per this HRA the gross salary is further calculated. Okay, so this is the equivalent code. That means the calculation of gross salary. Within main function, we have some variables of float type like BS, GS, DA, HRA. Okay, now we have printed a message, enter the basic salary. We have read the values of basic salary from the user. If the basic salary is less than 1500, then HRA and DA will be as per this calculation. And if it is greater than 1500, then this certain statement, that is HRA and DA, will be calculated further. And once out of these two statement is executed, then the final gross salary will be evaluated and printed on the output window. Okay, let's implement this code using code block. So again, come back to the code block window and create a new file. Okay, and just save this file. So again, go back to C project. Okay, create a new folder and write if. Now open this folder and save your C file. So we are done saving. Write the comment for the code description that calculating the gross. Again, include the header file. We need to define the variables like float, basic salary, gross salary, HRA and DA. Fine. Next thing is we need to print the message in the output window, which is done by using the statement called printf. Printf within inverted commas the message, that is enter the basic salary. Okay, so I can the print message like this. Now we need to read back the value, so reading the value from user. Okay, and for that we have the scanf. Here we are reading the value of basic salary, which is a float type, so the format specifier will be the %f. Okay, we need to assign the value to the variable called BS. Okay, so we are done with reading the value. Now we need to compare this value. So if BS is less than 1500, okay, start the curly brackets because we have more than one statement. So if BS is less than 1500, what we have to do is, now we have to calculate the HRA and DA based on this conditions. Okay, so for that, HRA is equal to the basic salary multiplied by 10 divided by 100. Okay, and next is DA, which is equal to basic salary multiplied by 90 divided by 100. Okay, so these are the statements for calculating the HRA and DA. So if the basic salary is less than 1500, then these two lines will be executed. And next comes is the else block. Now if the BS is not less than 1500, then we have array 500 and DA is equal to BS, that is basic salary, multiplied by 98 divided by 100. Okay, so we are done with the if else block. As you can see, there is a condition, that is if BS is less than 1500, and if this condition satisfies and gives the output true, then these two lines will be executed, and if it returns false, then the else block will be executed. And for that, next we have to say is the calculation of gross salary. So the gross salary is equal to basic salary plus HRA plus DA. Okay, and at last we will printing the value of this salary. Printf gross salary equal to RS. Okay, and we need to add here a value of float type, so I can write %f here and the value by comma, so the value is GS. Okay, and next is terminating the statement. So we are done with the code. Now let's build this code by clicking this. By clicking this icon, we have built the code and we have seen that there is no errors in this code. Okay, now let's run the code. Okay, so it is asking for the basic salary, so I'm giving 1400. Fine. So if I enter, I'll get the gross salary 2800. So this is the output value as compared to this HRA and DA calculation. Now if I run again and enter the value which is greater than 1500, so as you can see here, as per the condition expression, the output of this condition expression will decide what will be the gross salary of a person. Okay, so if the basic salary is less than 1500, so this particular set of code is executed, and if it is greater than 1500, then this particular set of code executed, and we have seen the output for both. Okay, so that's it for this session. In the next session we'll discuss about the switch case statement. Okay, so see you in the next session. Hello and welcome back to this course. In the previous two sessions we have discussed the decision control structures, that is if statement and if else statement. In this session we are going to discuss about the case control structures. So let's start. Now in real life we are often faced with situation where we are required to make a choice between a number of alternatives rather than only one or two. For example, which schools to join. So we have a number of options for that. Okay, which mobiles to purchase or which hotels to book for a holiday. Okay, so similarly the C program is same. The choices we are asked to make is more complicated than merely selecting between two alternatives. C provides a special control statement that allows us to handle such cases effectively rather than using a series of if statement. Okay, so like suppose we have a number of test condition or a number of choices, then we have to write a multiple if statements, right? But the C provides a special control statements which is used in such handy situation. Let's see how we can make decision using switch statement and how it is different from if else statement. So the switch case statement. Now the control statement that allows us to make a decision from the number of choices is called a switch, or more correctly a switch case default, since these three keywords go together to make up the control statement. Now this is the syntax for switch statement: switch, case and default. These three keywords combine to form the complete switch statement. Okay, now the expression following the keyword switch, that means this one, is any C expression that will yield an integer value. Okay, that means the output of this expression should be an integer value. It could be an integer constant or a character constant, or if it is an expression, then this expression should evaluate to an integer, and whatever integers will be evaluated, the keyword case is followed by that particular integer value or character value, and each constant case are different from each other. There will be no any similar values like value 1, value 2, value n. These will be different from each other. Code block. The code block lines in the above form of switch represent any valid C statement. That means with respect to this particular case, let's say value 1, what are the code that we want to execute? So we can write here. Okay, and once we are done with a particular case, we need to break this statement. So this break is used to terminate this switch statement. Let's take an example. There is a main function and we have int I equal to 2. Okay, so we have an integer constant having the value 2. So we have implemented a switch case with this value I. So I is equal to 2, and for it is 1, like for case 1 we have printf like I am in case 1. For 2 I am in case 2, and for case 3 I am in case 3, and for default I am in default. Okay, now if you run this code, you will get the output of the program I am in case 2, 3 and default. Okay, if you see the output, it is definitely not what we expected. We did not expect the second and third line in the above output. The program print case 2 and 3 and the default case. Well, yes, we said that switch execute the case where a match is found and all the subsequent cases and the default as well. That means this case 2 matches, and after that this, and this, all these three statements are executed. So that's why there is a need of a break function after every case constant. Okay, so case 1 printf the required message, and after that a break. Similarly for case 2 the required message and then break. Similarly for case 3 the message and the break. And you will see that after default there is no any break function, because this default will be executed if any of the case constant doesn't match. Okay, so if we run this code, we'll get the actual output that we will be expecting. Okay? Next thing is if else if ladder. Now this same scenario can be implemented by if else if ladder. Now what is this if else if ladder is that sometime in programming we need to test multiple condition back to back. Then if else statement does not fit for such kind of situation. So there is modified form of if else is used as shown. Okay, so this is the syntax for if else if ladder, like if then condition, and if it is condition is true, then this first condition will be executed, else another condition, like for second condition, the new condition is tested and required statement will be executed, and similarly keeps on testing multiple condition, and at the last we have an else block that if any of this condition does not satisfy, then at the end else block will be executed for false branch. So if you see, the execution of this if else ladder is equivalent as of switch. Okay, so we can perform the same scenario using this if else if ladder. We can execute one group of statement if the expression evaluates to true, and if the expression evaluates to false, then we can perform another test expression and follow the same execution pattern. The statement is used called as if else if statement, and the syntax for the statement is as we have discussed here. Now if you see, this if else if ladder and the switch case statement are both equivalent. That means we can use both of them to implement a similar scenario. So what is the difference between this switch versus if else ladder? Okay, the very first is the condition expression. Okay, now there are some things that you simply cannot do with the switch, and these are: a float expression cannot be tested using a switch, as we have seen that the expression in switch case statement is a constant value, whether it is an integer constant or a character constant. Cases can never have variable expression. That means we cannot write case a plus 3. We have to write a constant value like case 3, case 4, case 5, and so on. Multiple cases cannot use same expression, as we have already seen that the case constant have different values from others. But if else ladder support all these constant of switch case statement. Okay, that means we can test a float expression, we can test in variables, even multiple cases have same expression. Okay, second most important thing for switch is execution speed. Switch works faster than an equivalent if else ladder. Now this is because the compiler generates a jump table for a switch during compilation. As a result, during the execution, it simply refers the jump table to decide which case should be executed, rather than actually checking which case is satisfied. But in case of if else ladder, the evaluation is at the execution time, so the speed is slow as compared to switch. Okay, but there is a contrary, like if there is one or two condition test, then if else will work faster than the switch, because switch will have to create a jump table and then refer that jump table to execute a particular case. Okay, so whenever there is a number of choices increasing more than 5 to 6, then it's better to use switch instead of if else ladder. Okay, now let's understand with an example in the code block. So let's move to the code block section. So get back to the code block window, again go to file, click a new empty file and save this file to the C projects. Okay, so again create a new folder, write switch. Now open this folder and save the C file here, switch demo you can write, and click save. Okay, write comment demonstration for switch statement. Okay, so the very first thing that we are doing is including the header file. So stdio.h within angle brackets. Now void main starting the curly brackets. Okay, now what we are going to do in this is we will be receiving a number from 1 to 7, and for each numbers received we have to display the equivalent weekday. Okay, like for 1 it is Sunday, for 2 it's Monday, and so on. So let's take int num. Okay, so we have defined a variable int num. Now we are printing the message for the output window, that is enter the number from 1 to 7. Okay, so we have printed the message for entering the number between 1 to 7. Okay, now we are reading it. So scanf, we are reading the integer value, therefore specify format d, %d format specifier, and next we are storing the value at num. Okay, so we have printed the message, we have received the value from the user. Now we are applying switch case. Okay, so switch, the expression is num, which is the character constant. Okay, now we have to define the very first case, which is 1, and we have to printf for case constant 1, which is equal to Sunday, and /n for new line. Okay, so there is very first case constant, that is if the number is 1, we'll print Sunday. Okay. Next, similarly, we can paste the code for 1 to 7. Okay. That means Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, and Saturday for 7 cases. And last one is default case. Okay. So at the default, I can write printf wrong number. Okay. So we are done with the code. Go to build, and you will see the build finished with 0 errors and 0 warnings. Okay. Now run this code. As you can see, the message has been printed like enter the number from 1 to 7. Let's say I'm entering 5. You can see that after case 5, Thursday, Friday, Saturday, and wrong number, all 4 of these has been printed because we have not used the break function. Okay. That's why whenever the case match with the 5, so it executed this statement and following all the statements for various cases, whether it matches or not. So whenever there is a match, it will execute all the statements after that. Fine. So let's make the required changes. So what I'm doing is I'm adding the break function every case. Okay. So I'm copying this for enter, paste. So we can paste the break function after every case statement. Okay. So done. Now let's again build and run the code. Okay. So again we get the output message that is enter the number from 1 to 7. Let's say I'm entering 2. So I'll get only Monday. Okay. And rest of things will be not executed. So this is the function of a switch case statement. Similarly, run again and try entering different values. Let's say I'm entering 5. So I'll get Thursday. Okay. So I hope that the statements for the decision control as well as case control is clear to you. If you have any queries related to any statements, feel free to reach us. Okay. So that's all for this session. Hello and welcome back to this course. In this session, we are going to discuss about the loop control structures. So let's start. As you know, almost always if something is worth doing, it's worth doing more than once. You can probably think of several examples of this from real life, such as eating a good dinner, watching movies, an office job. So these kind of tasks are done repeatedly. Programming is the same. We frequently need to perform an action over and over, often with variation in the details each time. The program that we have developed so far used either a sequential or a decision control instruction. So in the sequential statement, the instructions were carried out in a fixed order, while in decision control an appropriate set of instructions were executed depending upon the outcome of the condition or logic being tested. The versatility of the computer lies in its ability to perform a set of instructions repeatedly. Now this involves repeating some portion of the program either a specified number of times or until a particular condition is being satisfied. The repetitive operation is done through a loop control instructions, and there are 3 methods or way by which we can repeat a part of program. They are using a for statement, using a while statement, and using a do while statement. So we'll be discussing all of them one by one. So let's start with for loop. A for loop is a repetition control structure which allows us to write a loop that is executed a specific number of times. The loop enables us to perform n number of steps together in one line. Here's the syntax for loop. That means a keyword for is used, and within brackets there are initialization expression, test expression, update expression, and after the curly brackets the statements that will be the body of the for loop, which will be executed depending upon this test expression. Okay, so let's discuss what are these components. Initialization expression. Now this expression used to initialize or define the starting value for the loop counter. That means from where the loop will start. Next is test expression. Now this expression used to test the loop counter to determine whether its value is reached the desired number of repetition. That means if I have defined a value n, then we have to test whether the loop counter value is reached to n number of repetition or not. So if the condition evaluates to true, then the body of the loop will be executed. Next is update expression. Now this expression updates the value of loop counter each time the body of the loop has been executed by incrementing or decrementing the loop variable by some value. That means whenever this body of the loop will be executed, then the update expression is performed, and update can be increment or decrement in the loop variable. Let's understand with the help of an example. So this is an example that is calculation of simple interest for 3 sets of P, N and R. Okay. If you remember, we have written this program for calculating the simple interest value in the very first session. So here we are going to perform this simple interest multiple times. So if you see, within main function, we have defined the same variables. There is one extra variable called as count. Now within for loop, this count is equal to 1. Now this is the initialization value, that is starting value of count, that it will start from 1 and it will go to the maximum 3. That means the count will be compared to 3. And if it is less than or equal to 3, then this body will be executed. Okay. So in the body of the loop, we have printed the message to enter the value from P, N and R from the user side. And we have just read those value and stored in the required variable. Next, we have calculated the simple interest by the given formula and printed the final result. Okay. So once this body of the loop will be executed, this will comes to this update expression. That means count is equal to count plus 1. So starting value was 1. Now it will become 2. And again, this will be tested whether this 2 is less than or equal to 3 or not. So if it is true, then again this body will be executed, and again after the execution it will increment to 3. So 3 is again equal to 3. So it will again execute the same body of the loop and again go to count variable. So when incrementing this count again, it will become 4 and this condition just returns false. 4 is not less than or equal to 3. So as soon as this test condition returns false, this body of the loop will be exited. Okay, you can see the same scenario by this flow diagram. So here the code start, it is the value of count 1, then it is tested that is count is less than equal to 3 or not. If it is yes, then input is taken from the user and simple interest is calculated, and finally the result is printed. And it again came back to count equal to count plus 1, that is the update expression. So again testing, and when this condition returns false, that means no, it will stop. Okay, so we'll write this code in our code block session. For now, let's see the various forms of for loop. If we do not add parameter to the for loop and leave every expression blank with semicolon, then for loop will become infinite loop and will keep on executing for an infinite number of times. So as you can see, for, and we have not added any expression, whether initialization, test or update. So I have added just 3 semicolon, and if you execute this loop and write anything within the body, that will be executed infinite number of times. Okay, let us now write down the program to print numbers from 1 to 10 in different ways by using for loop. And the for loop can be written in any of these mentioned forms, and the output results will be same for each case. Okay, as you can see that the initialization, testing and incrementation of loop counter is done in the for statement itself. Instead of I equal to I plus 1, we can use I plus plus, okay, or I plus equal to 1. Since there is only one statement in the body of the for loop, the pair of braces has been dropped, okay, because single statement can execute without the curly brackets, because the default scope of the for is immediately the next statement. Next, you can see the variable has been defined, the initialization expression and the test expression. So the incrementation is done within the body of the loop. Okay. In spite of this, the semicolon after the condition is necessary. That means if I'm writing this incrementation operation within the body, then I have to add a semicolon here. Okay. Because this is in the syntax itself. Next, here the initialization is done in the declaration statement itself, but still the semicolon before the condition is necessary due to the same reason. Okay, that means if I have declared the initialization expression before the for loop, even then I have to add a semicolon for initialization expression. Next, here neither the initialization nor the incrementation is done in the for statement. Okay, but still the 2 semicolons are necessary. One is for the initialization and other one is for incrementation or update expression. In this form of for loop, you will see the comparison as well as incrementation is done through the single statement like I plus plus less than 10. So since the plus plus operator comes after I, firstly comparison is done followed by incrementation. Okay, note that it is necessary to initialize I to 0. And at last, in this form of loop, both the comparison and the incrementation is done through the same statement, that is plus plus I less than equal to 10. Now since plus plus precedes I, so firstly the incrementation is done and then comparison will be done. So these are some various forms of loop. That means for loop can be written in any of these manners and all of them are valid and you will get the same result. Okay. Now let's come back to the code block window. So you can just go to file, create a new file as we are doing for every session. So empty file has been created. Now you can save this file at the desired location. Okay. So I'm creating a new folder in the C project, which is for_loop, the name given to that folder. Okay. Now open this folder and save the .c file here. So you can write the same name for the file and click on save. Okay, so now let's try to write the same code for calculating the simple interest 3 times. Okay, so if you want, you can add comments like calculation of simple interest for 3 sets of values of P, N and R. Okay, so let's start by writing hash include standard input output dot h. Start the main function by writing void main. Define the required variable, that is int p comma n count. Next, the float data type for rate of interest and simple interest. Now you can write the for loop. So for count equal to 1 semicolon, count less than equal to 3 semicolon, and count plus plus. Okay, so now again create the curly braces, again start the curly brackets and write the body of the loop. So printf, the message to be printed, that is enter the value of P, N and R. Okay, add the semicolon. Now we have to read the values. So again scanf, within double quotes write the format specifier, that is for %d, that is integer data type for P and N, and %f, that is float for rate of interest, that is R. So you can write %p comma %n comma %r. Okay, so I have read the value of P and R and save in the required variable. Now just calculate the simple interest by the formula, that is P multiplied by N multiplied by R divided by 100. Okay, and finally printf simple interest is equal to RS specifier for the float data type and /n for printing the data in new line. Now I am assigning the value of SI. Okay, we are done with the code. Okay, now just click on this build icon and you will see the build finished with 0 errors and 0 warning. So just click on run. Okay, so you will get the message for entering the values of P and R. Okay, so I'm writing the value 1500 P 8.5. I have got the value of simple interest, that is rupees 382.50. Now as you see, after printing the simple interest, it is again asking the value for P and R. Okay, that means the body of the loop has been executed once. Okay, now again enter the value, something different. So 1200, 2 and 6.8. You will see it again printed the simple interest. Okay, and again asking the values for P and R. So let's try one more time. 100, 1, 8.4. Now you see, after entering the values for the third time, the simple interest has been printed and the code has been terminated. Okay, so this for loop has executed 3 times. That is the desired value of loop variable that we have assigned and tested, and the starting value is 1. So 1, 2, 3. The code executed 3 times. So I hope the for loop is clear. If you have any doubt, feel free to reach us. And welcome back to this course. In the previous session, we have discussed about the for loop. Now in this session, we are going to discuss the next loop instruction, that is called while loop. A while loop is a control structure that keeps executing its body repeatedly as long as the specified condition remains true. The loop counter is initialized outside the loop and updated inside the body of the loop. Here is the syntax for while loop. Okay, so it contains all the similar expression that we have discussed in the previous session, that is initialization, condition as well as update expression. But the difference is the initialization expression is executed before the loop or outside the loop. Okay, within while, that means in the while statement, conditional expression is tested and the update expression is executed inside the body of the while loop. As long as this condition is satisfied, the conditional expression returns true. The body of this while loop will be executing repeatedly, okay? And inside the body of the loop, the expression is updated and again tested back to back, okay? Let's take an example. The same example that we have performed using the for loop can be written using while loop, okay? So the same variables have been defined with count equal to 1. Now, while count is less than equal to 3, that means the test condition is written within while, okay? So while count is less than 3, this body of the loop will be executed and you will see at the end count is equal to count plus 1, that is update expression, okay? So as long as count is less than equal to 3, this body of the loop will be executed, and after the execution this count will be incremented by 1. You can see the equivalent flow diagram. Here the code start, count is initialized by 1. Now it is tested that is count is less than equal to 3 or not. So if it is less than equal to 3, then input is taken from the user, simple interest is calculated and printed on the output window, and once this body of the loop execute, at the end we have count equal to count plus 1. That means the incrementation is done inside the loop body, and once the loop counter is updated, it come back to the test expression. So until this test expression evaluate yes, it keeps on executing, okay? And as soon as it returns no, the code will be stopped. Now let's come back to the code block window and try to implement the same code using while loop. So again go to file, or you can simply create on this new file, empty file, Control S to save, okay? And here you can write within the same folder, you can create another C file writing the name while underscore loop, okay? So save this file. If you want, you can add comment demonstration of while loop by including the header file, that is stdio.h the main function, define those same variable. Now initialize the value, that is count equal to 1. Now while, okay, this is the keyword, so you have to write all in small. So while count is less than equal to 3, okay? Now you can start the body of the loop, and again you can write the same set of codes written in the previous session, okay? So enter the value of p n r, okay? You can read the value by scanf function. So %d, %f, reading, storing the value in the required variable by %p, %n, %r, okay? Now calculate the simple interest by p multiplied by n multiplied by r divided by 100, okay? And you can print the exact output. Simple interest is equal to %f si, okay? At the end we can write count equal to count plus 1, okay? We are done with the code. Now build. You can see the build finished with 0 errors and 0 warnings. So click on run, okay? You will see the same output message like previous one. Now enter the value. So now as you can see, the simple interest is printed, but next the enter the value of p and r is printed in the same line. Why? Because here I forgot to mention new line character, okay? So you can just close this window and mention here /n, okay? Again build the code and run, okay? So again let's try to enter the value. As you can see, after printing the value of simple interest, the message has been printed in the new line, okay? Try entering with different value one more time. Even this code has been executed for the 3 times. So you can say the same functionality can be defined using while loop. If you have any doubt in this while loop, feel free to reach us, okay? So see you in the next session. Hello and welcome back to this course. In the previous session we have discussed about the while loop, and now in this session we are going to discuss about do while loop. So let's start. Now, sometimes we come across a situation when it is not known beforehand that how many times the statements in the loop are to be executed. Then do while loop comes into picture, which is similar to while loop. Here are the syntax for the do while loop. Okay. Again, the components are same, like initialization expression, conditional expression, update expression. Okay. In the do while loop, again the initialization expression is executed or written outside the loop, and update expression is executed within the body of the loop. Okay. But the difference is the conditional expression is tested at the end of the loop. That means once the body of the loop is executed, then the conditional expression is tested, and if the test returns true, then it again executes the body of the do while loop, otherwise it quits the loop. Okay, let's understand with an example. So you can see the same example that we have performed using for loop and while loop. The same functionality can be defined using do while loop. So in the main function, the same variable have been defined, and there is a initialization for count value 1. Okay, now the do while loop's body start, and within do while we have printed the same message to enter the value of p, n and r. Okay, and we have read the values and stored back to these variables. Now the simple interest has been calculated and printed as an output, and the count values updated. Now once this body of the loop will be executed, then the condition is tested that while count is less than equal to 3. So if this condition satisfied, the body of the loop will be executed again, otherwise it just quit the loop. Okay, you can see the equivalent flow diagram. Here the code start, count is initialized by 1, then input is taken from the user, simple interest is calculated and printed on the output window, and once this body of the loop execute, at the end we have count equal to count plus 1. That means the incrementation is done inside the loop body, and once the loop counter is updated, it come to the test expression. So until this test expression evaluate yes, it keeps on executing. Okay, and as soon as it returns no, the code will be stopped. So we'll see the output of this code in the code block session. Okay, now while versus do while loop. Okay, you have seen the syntax is very much similar of while and do while loop. So what is the difference? The very first is testing of condition expression that we have just seen, that in while loop condition is tested at the beginning. Okay, so it is kind of an entry controlled loop. That means if the condition returns true, then only the body of the loop will be executed. But in a do while loop, the condition is tested at the end. Okay, so the body of the loop will execute until the test condition remains true. So it's a kind of exit control loop. That means the condition is tested at the exit point. Okay, next difference is the execution of loop body. That means in case of a while loop, if the test condition returns false, then the body of loop will not be executed, and it will be executed if the condition is true. But in case of do while loop, if the test condition return false, even then the body of the loop will be executed once, as the condition is tested at the end of the loop. Okay, so the do while loop will execute once for sure. Now let's get back to the code blocks window. Create a new file. Okay, save this file and name it as do while underscore loop. Don't forget to add .c extension. Click save. Now just try to implement the same code that we have discussed in the example. Okay, so you can add comment. So start by writing hash include stdio.h. Okay, start the main function. Now define the variable for p and float type variable for r and si. Okay, now you can write count equal to 1 initialized value, which is the initialized value for count. Now you can write do, start the curly brackets and printf the same message. Okay, enter the values for p, and we can read the value using a scanf, and d for p, %d for n, and %f for r. Okay, so assigning the value of p, n, so you can calculate the si, which is equal to p multiplied by n multiplied by r divided by 100. Okay, so now printing the result, simple interest is %f and /n for new line, and writing the value of si on the output window. Okay, and at the end we can define the loop variable count by, so we have incremented the count equal to count plus 1, and after the loop we can write the test condition for while, which is less than equal to 3. And so we are done with the code. Now click on this build icon and you will see the build finished with 0 errors and 0 warnings. Now click on this run. Now enter the values for P and R. So let's try 1500 simple interest value. It is asking again, so 1800. 4, 8 is asking for the third time, so 100, 3 and 4. We'll see that after executing the code 3 times, it quits. The loop body exit. Do while is clear. I hope now do while loop is clear to you. If you have any doubt, feel free to reach us. So that's all for this session. In the next session, we'll see the nested loop. Okay, that how we can use loop within a loop. Okay, so see you in the next session. Hello and welcome back to this course. In the previous few sessions, we have discussed the for loop, while loop and do while loop. Now in this session, we are discussing about nesting of loops, that how we can use loop inside the body of a loop. Okay, so let's start. We can use multiple loop within a loop, which is normally called as nesting of loops. Nesting of loops is used when there is a need to control multiple count variable to achieve desired objectives. Let's understand with this example. Here you will see there are two count variable, that is R and C, another variable for sum. Now there is a for loop in which R is initialized with 1 and compared to 3 and incremented by 1. Okay, so this is the outer loop, and within this for loop there is another for loop which is initialized by C equal to 1 compared with C less than equal to 2 and incremented by 1. And within this body of the for loop, sum is calculated by adding R plus C and the result is printed. Okay, so here for each value of R, the inner loop is cycled through twice. Okay, and with the variable C taking values from 1 to 2, the inner loop terminates when the value of C exceeds 2. That means C start from 1, maximum of twice, and the outer loop terminates when the value of R exceeds 3. Okay, that means third time. That means the third time. So as you can see, the body of the outer loop, okay, this outer for loop is indented. Body of the inner for loop is further indented, and this multiple indentation make the program easier to understand. That means this is the curly brackets for the outer for loop, and within this we have the desired operation. Okay, we have calculated the sum and printed the result. So we can simply connect these two statements by single statement, writing here sum equal to R plus C. Okay, we'll try to run this code in the code block session. Okay, so let's jump to the code block window. So create a new file again, save this file, give the file name as nested_loop.c. Okay, so you can write the comment demonstration of nested loop. Okay, so start by including the standard input output.h. Okay, start the main function. Now define the variable. Okay, int R comma C comma sum. Fine. Now we have to define for loop. So for R equal to 1, 3 R plus plus. Okay, here you can start the curly brackets, and within this again we have to define a for loop. So C equal to 1, C less than equal to 2, C plus plus. Okay, now within this we can write sum equal to R plus C, printf the result. We can write R equal to %t, that means the value that we will assign. Next C equal to %d again, and sum equal to %d and /n for new line. Pass the variables after comma. So R comma C comma sum. Okay, so we are done with the code. Now just click on build. You will see the build finished with 0 errors and 0 warnings. Okay, now click on run. So you can see this output. Okay, R equal to 1. So for R equal to 1, C has been executed 2 times. Okay, that means C 1 2 and the sum is 2 and 3. That means R is equal to 1, R less than equal to 3 is condition true, so it enters the body of the first loop, and in the body of the first for loop we have another for loop in which C is the loop variable count starting from 1 and going to maximum 2. So for C1, it has printed the value by adding R plus C and come back to this C++ and increment by 1 and it becomes 2. So again it added the value of R and C and printed the sum. Now after completing this for loop, the control reaches to R++ and it increment the value of R to 2. So for 2, again this loop will execute 2 times, and after executing again it comes to R++ and increment to 3. Okay, so as you can see the output, R has been 1, 2, 3 and C is 1, 2. So C has been executed twice for each value of R. Okay, so I hope this code is clear. So that's all in this session. If you have any doubt, feel free to reach us. Okay. Hello and welcome back to this course. In the previous session, we have discussed the nesting of loops. That is, how we can implement multiple loops inside the other loop. In this session, we are going to discuss two important statements that is most frequently used to control the flow of nested loop. Very first is the break statement. Now we often come across situation where we want to jump out of a loop instantly without waiting to get back to the conditional test. Okay, the keyword break allows us to do this. When break is encountered inside any loop, control automatically passes to the first statement. Break is usually associated with an if. So here is an example in which we have a main function, two variable initialized with num, and I have read the value of num from the user. Initialize the value of I equal to 2, while I is less than equal to num minus 1, num modulus I is equal to 0. If num modulus I equal to 0, we have to printf not a prime number and just break the loop. Okay. In this program, the moment num percent I turns out to be 0, that is num is exactly divided by I, the message not a prime number is printed and the control breaks out the while loop. Okay, that means this while loop is, there are two ways the control could have reached outside the while loop. One is if this condition satisfied, that means the number is exactly divided by I, then it is reached outside the while loop and it jumped out because the number proved to be not a prime. That means this number is exactly divided by this I. Okay, and another way is the loop came to an end because the value of I became equal to num. That means this loop completes its repetition and I is now exceeded the value of num minus 1. So the counter value exceeds the test condition and hence it just quits the loop and come outside the body. Okay, and at last it compares the value. If I is equal to num, then printf prime number. Okay, so the keyword break breaks the control only from the while in which it is placed. That means if there are multiple while loop, then the break placed in the while loop will breaks only. Okay, that means if there is another while loop, then only this while loop will break, not the other one. Okay, we'll try to run this code in the code block session. Okay, so let's jump to the code block window. So create a new file again, save the file and write break.c. Okay, you can comment demonstration of break statement. Now we will implement the example code for break statement. So let's start by including the header file. Now start the main function. Define the variable int num comma I semicolon. Next we have to print the message in the output window. Printf enter the number. Now read the value and store it to the num variable. We can write scanf within double quotes %d comma ampersand num. Now let's initialize the value of I equal to 2. Now we can write a while loop for I less than or equal to num minus 1. Start the curly brackets. Now test that if num modulus I is equal to 0. That means the number is totally divisible by I. Then we have to printf the message not a prime number. Here we can use break statement to jump out of this while loop. Okay, now write I++ for updating the loop variable count, and outside the loop we have to again test that if I is equal to num, we have to printf the message prime number. You can understand by looking at this function that this function is used to test a entered number whether it is a prime or not. Okay, Now what is prime number? Prime number is basically a number that is divisible by 1 or itself, okay, such as 3, 7, 11, 13, because if you divide this number with any other, that will not be divisible, okay. So the same logic has been written here. I is starting from 2, that means 1 is skipped. So from 2 to the num minus 1, that is if we are taking number 13, then from 2 to 12, this 13 number is tested whether it is exactly divisible by that number or not. So if it is divisible by that number, that means it's not a prime number, because prime number is not divisible by the numbers other than 1 or itself, okay. So as soon as it returns true, that means any number divides the given number, then it's not a prime number, and just break. That means you can quit from the loop, okay. And you can test here that if I equal to num, so if num is divided by I, then obviously I is not equal to num. This condition will be satisfied only when this loop will complete the counter from 2 to num minus 1, okay. So that means if the number is not divided by any of the number between 2 to num minus 1, then it's a prime number, okay. So let's build the code and you will see 0 errors and 0 1. Now let's run the code, okay. So now just enter the number. I'm entering 12, okay. It has shown that it's not a prime number, okay, because 12 is not a prime number. Try running once again. This time I'm entering 13 and you will see the output shows prime number, okay. So that is the use of break statement, that whenever you want to jump out of the loop body, you can call this break statement, okay. So I hope that the break statement is clear to you, okay. If you have any doubt, feel free to reach us. Hello and welcome back to this course. In the previous session we have discussed about the break statement. Now in this session we are going to focus on the next important statement, that is continue statement. In some programming situation, we want to take the control to the beginning of the loop by passing the statements inside the loop which have not yet been executed, okay. The keyword continue allow us to do this. When continue is encountered inside any loop, the control automatically passes to the beginning of the loop. Continue is usually associated with an if, like the break statement. Here is an example of continue statement. So within main function there are two variables defined, I and j. So two for loops are there. One is for I equal to 1 less than equal to 2 I plus plus, and within the body of this for loop we have another for loop for j equal to 1 which is counting up to j less than equal to 2. So within the body of inner for loop you will note that when I is equals to j, the continue statements takes the control to the inner for loop. That means when this continue statement is encountered, the control is transferred to j plus plus, okay. And again it is compared with less than equal to 2, and if it is true it comes to the body. Now if this conditions returns false, then the printf will be executed. So as you can see the output of this above program, when I is equal to j, this printf is bypassed, and when it is not equal, then the value is printed. So 1 2 2 1. This is the output for this above code, okay. Nested loops are mostly used to generate various pattern in C, okay. A very basic pattern shown below, having the stars that is incrementing at every next line, okay. So in the next session we will see how to generate these kind of patterns using nested loops. For now, let's jump to the code block window and implement the example of continue statement. So let's jump to the code block window. Again create an empty file, save this file to loop folder as continue.c. Okay, so just save this file and you can write comment as demonstration of continue statement. Once again start the code by including header file stdio.h, then the main function. Now let's define the two variable, that is int I comma j. Now we have to create for loop for I equal to 1, I less than equal to 2, I plus plus. Inside the body of this for loop we have to create another for loop. So for j equal to 1, j less than equal to 2, j plus plus. Now inside the body of this for loop we have to test that if I is equal to j. So if I equal to j, we have to use continue statement. After that just print the message /n %d /n. We are printing the value of I and j. Now if you see this code, so there are two for loop used. The upper for loop is from 1 to 2. Same is for the inner for loop, and within the body of this inner for loop we have tested that if I is equal to j. Okay, so for I equal to 1 the condition is true, then it enters the second loop. Okay, in the second loop again the condition is true, so it enters the if statement. Okay, now if I is equal to j, for now I and j both are 1. Okay, so since I is equal to j, we have a continue statement. That means the control will be transferred to this for loop of j. So again j is incremented and retested. Okay, so this time I equal to j returns false. Okay, so continue will not be executed, rather than this printf will be executed. So let's build the code and run the code to see the output. So you can see that when I and j are not equal, then only the value of ij is printed, that is 1 2 2 1. And for the other condition like 1 1 2 2, since I is equal to j, continue statement has not allowed the loop to execute further statement. It just transferred the control to the start of the loop. Okay, so I hope the working of continue statement is clear to you. If you find any difficulties, you can reach us. Okay, and for your reference, this code. Hello and welcome back to this course. In the previous session we have discussed about nesting of loops. Okay, and the important statements like break and continue. Now in this session we are going to see the application of nested loop. Okay, so basically these nested loops are used to generate various kinds of patterns. Okay, like uniform stars, stars as a pyramid, increasing as well as decreasing, central, numbers, increasing, decreasing. Okay, there are lots of patterns that can be generated using the nested loops. Okay, so we'll see how we can generate this kind of pattern. Okay, let's start with the code block window. Create a new empty file, save, create a new folder for patterns. Okay, give the name pattern1.c, click save. Add the comment as pattern1, include, start the void main function, define the two variable, let's say int I comma j. Okay, here the variable I will be used to control the row and j will be used to control the column. Okay, so we can use nested for loop. So for I is equal to 1, I less than equal to 5, I plus plus. Okay, so we are displaying for 5 rows. Okay, now within it again we can use for loop. So j equal to 1, j is also less than equal to 5, j plus plus, and within this we can write printf star semicolon. Outside this loop we will printf the new line. That's it. Just build and run the code. Okay, so you can see 5 stars are printed in 5 rows. Okay, I hope the flow is clear, that outside for loop is controlled when the inner for loop is completed from 1 to 5. That means for I equal to 1, j is from 1 to 5 and printing 5 stars, and after that new line and I is incremented to 2. Okay, so in the next second line again j is from 1 to 5. Similarly for third, fourth and fifth line. Okay, let's create another empty file. Save this as pattern2.c within the same folder. You can just copy this code, paste here, and there is slight change. Instead of star, just write %d and comma j. Now if you will build and run this code, you will see the stars are replaced by the values of j, that is 1 2 3 4 5. Okay, now create one more empty file. Save this file as pattern3.c and paste the code. Now here just remove the test expression as j less than equal to I. Okay, now let's build and run the code. Now you will see the output as triangular stars increasing at each line. Okay, now again if we replace the star by %d comma j, then it will be printed as 1 1 2 1 2 3 1 2 3 4 1 2 3 4 5. Okay, so let's try this. Modify within the same code. Now let's build and run the code. This is the output. Okay, let's create one more empty file. Save this as pattern4.c. Okay, again paste the same code. Now here just modify the outer loop which will be decreasing, that is for I equal to 5, I greater than equal to 0 and I minus minus. Okay, and in the test expression of inner for loop, j should be less than equal to I. Okay, now let's try to build and run the code. So now you can see the output as decreasing triangle of stars. Okay, similarly if we again modify this using %d comma j, we'll get the stars replaced by the value of j. Okay, so let's build and run the code. So here's the output. Okay, so similarly you can design number of patterns. Okay, let's try one more. Create a new empty file again, save this as pattern5.c, paste the same code. Let's add one more variable k. Within the main for loop, just define another for loop. So for k equal to 5, k greater than equal to I, k minus minus, and within this loop we have to printf space. Okay, and in the second for loop, j is less than equal to I. So let's now try to build and run the code. You will see the output as aligned star pattern. Okay, now if we add space within the star and now build and run the code, you will see the perfect center pyramid. Okay, so similarly by modifying the parameters in the for loop, you can generate the multiple patterns. Okay, so I hope the application of nested for loop is clear. You can explore number of patterns for your practice. Okay, so that's all for this session. See you in the next. Hello and welcome back to this course. In this session, we are going to discuss about functions in C. Knowingly or unknowingly, we rely on so many persons for so many things. Okay, man is an intelligent species, but still cannot perform all of life's tasks all alone. Okay, he has to rely on others. Similarly, a computer program, except for the simplest one, finds itself in a similar situation. It cannot handle all the tasks by itself. Instead, it requests other program like entities called function in C to get its task done. Suppose you have a task that is always performed exactly in the same way. Say a bi-monthly servicing of your car. When you want it to be done, you go to the service station and say it's time to do it now. You don't need to give instructions because the mechanic knows his job. You don't need to be told when the job is done. You assume the car would be serviced in the usual way. The mechanic does it and that's that. Using a function is something like hiring a person to do a specific job for you. Sometimes the interaction with this person is very simple, sometimes it's complex. Okay, so let's see the function. A function is a self-contained block of statements that perform a coherent task of some kind. Every C program can be thought of as a collection of these functions. Okay, so let's understand with an example. So in this example, main itself is a function and through it we are calling the function message. Now what do we mean when we say that main calls the function message? We means that the control passes to the function message. Activity of main is temporarily suspended. It falls asleep while the message function wakes up and goes to work. When the message function runs out of statement to execute, the control returns to main and which comes to life again and begins executing its code at the exact point where it left off. Okay, that means this is the main function and within main there is a call to message. So this call means that the control is transferred to this function and within this function this particular statement is executed and after that there is no any other statement. So it just transfer the control to back where it has come from. And here the printf is done for this particular statement. Okay, so you can see the output that smile and the word smiles with you. That means this is the output of the message function, and cry and you stop the monotony. So this is the execution of main function. So thus main becomes the calling function whereas message becomes the called function. Now why use function? There are two reasons. The very first is writing functions avoids rewriting the same code. Suppose you have a section of code that calculates area of triangle. So if later in the program you want to calculate the area of a different triangle, you are required to write the same instruction all over again. So function will avoid writing the same code. Second reason is using function it becomes easier to write programs and keep track of what they are doing. Okay. Now, if the operation of a program can be divided into separate activities and each activity placed in a different function, then it makes the program easier to design and understand. So basically, there are two categories of function: library functions and user-defined functions. Okay, so library function we have been using in the multiple sessions like printf, scanf. So these are the functions that are defined in libraries. Okay, and which library? The standard input output.h. And second is user defined functions that we are going to discuss. That means that will be defined by us. So the component of functions are function definition, function declaration, and function calling. Okay, now what are these three? We'll discuss in the next slide. So here are the syntax for definition. That means how we can define a function. So if you see, there is a return type, then the function name, within the parenthesis the parameter list, and after that there is a curly brackets and the body of this function. Okay, and this defines the working of function. Now what are this return type, function name, parameter list? So let's discuss one by one. Return type. Now a function may or may not return a value. The return type is the data type of the value the function returns. If the function performs the desired operation without returning a value, then the return type is the keyword void. So if you see in the previous example, message, the message has been displayed only and we don't have any return data. Okay, that's why the return type of message is void. Okay, or empty. Next is function name. Now this is the actual name of the function. The function name and the parameter list together constitute the function signature. Okay, so the name can be given as normal routine naming convention. Next is parameters. Now the parameter list refers to the type, order and number of parameters of a function. Parameters are optional. That means a function may or may not contain parameters. Like in the previous example of message function, there were no any parameter. At last, the function body. The function body contains a collection of statements that defines what the function does. That means the functionality of this particular function will be defined within the body of the function. Next is syntax for declaration. Okay, return type, function name, parameter list and semicolon. That means if you want to declare a function, then we have to follow this syntax. Declaration tells the compiler about the function defined in that particular code. Okay, so it's just inform the compiler that there is a function named this having these parameter defined in this code. Okay, and compiler just get familiar about the function. So whenever the function is called by this syntax, that is calling the function name with the values of parameter semicolon. Okay, so whenever this function is called, the compiler know that there is a definition in this code for this particular function. Let's understand with the example sending and receiving values between function. Okay, so we have a function cal sum that will calculate the sum by the values of parameter like x, y, z. Okay, so you will see the return type and the type of parameters is defined here, int x, y, z. Alternatively, you can write int cal sum within bracket int x, int y, int z. So that will be the standard syntax for function definition, having the return type, the name of the function and the parameter list. So in this program, from the function main, the values of a, b, c are passed on to the function calsum. Okay, by making a call to the function calsum and mentioning a, b, c in parenthesis. That means we have read the value of a, b, c from user. Okay, and pass this value to the function calsum. So as soon as this calling is done, the control is transferred from main function to this calsum function. And here the x, y, z copies the value of a, b, c and just add the value and store the result into the variable d. And at the end, the d is returned so that the total sum of x plus y plus z is stored in the variable sum. Okay, so as soon as return statement is executed, the control is transferred back to the main function. Okay, and finally the sum is printed. So all this process is written here. The variables a, b, c are called actual arguments because these contain the actual value, whereas the variable x, y, z are called formal arguments. Okay, now the type, order and number of the actual and formal argument must always be same. Okay, that means ABC is of int type. That's why XYZ is also of integer type. Now a function can return only one value at a time. Okay, if you don't want to return any value, then we must define it by writing void. That means if this function does not return any value, then we can define here void data type for this function return. Now the return statement serves two purposes. Very first is on executing the return statement, it immediately transfers the control back to the calling program. Now it returns the value present in the parenthesis after return to the calling program. So this function is called, so return d will be sending the value of d to this variable sum. So if the values of formal argument is changed in the called function, the corresponding change does not take place in the calling function. Of course, like if there is a change in the value of x, y, z within this function, that will not going to affect the value of a, b, c. That will remain the same, that will be entered by the user itself. So we'll test this code in the code block session. Let's jump to the code block window, click on new, empty file, save the file, create a new folder for the function. Now open here and you can just write the another C file called function 3 because we have function 1 and 2 already available in this folder. So click on save. You can write comment like demonstration of function. Okay. Now write hash include io.h void main, start the curly brackets, define the variable int a comma b comma c comma sum. Now print the message that is into the value of a, b and c. Okay, and read the values %d, %d. That means that specifier for integer data type. And now for the value of a, b, c. In order to calculate sum, we will call the function cal sum by passing the variable a, b, c. Okay. At the end, printf the new line sum is equal to %d and we'll assign the value of sum. We'll be defining the cal sum. Okay. So the cal sum will return the total sum of integer data. So we'll write int cal sum. Okay. It takes 3 parameters, that is int x, int y, curly brackets, and define that will store the value of result is x plus y plus z, and at the end we can return t. So this section is function definition, here calling of function, and now before the main function we can declare that is int cal sum, int x comma int y comma int z and semicolon. Okay, so this is declaration. Okay, so we are done with the code. Now the function is defined within the same code. So if we don't declare this function, that will be also okay. Okay, that will not going to create any errors. So this is the function declaration part, main function in which a, b, c value has been read from the user, and for calculating the sum we have this value of a, b, c to another function which is cal sum and having the 3 parameters. So this x, y, z will copy the value of a, b, c, store the output into d, and finally this d value is returned and stored into variable sum. So finally the sum will be printed. Okay, so let's build the code and you will see the build finished with 0 errors and 0 warning. Okay, now click on run. You can see the output into the value of a, b and c. Okay, let's enter 10, 25, 36. You'll see the sum is calculated at 71. Okay, so after storing the value of a, b, c, the main function call this cal sum function with the same values, and this cal sum function gives the total result into some variable. If you need, you can practice as more as codes for defining a function and calling them. There is another example for main function and user defined function. In this we have defined a display function that will print just a message, and in the main function that display function is called. Okay, so if you build this code, you will see the build finished with 0 errors. If you run, you will see the output as I am in the main function, that is the first printf, and after that display function is called, so the control is transferred to this display and printed this I am in the function body. Okay, and after the execution of this statement, it come back to the main function and printed back to main function. So that's all for this session. See you in the next one. Hello and welcome back to this lecture. In the previous session we have discussed about the functions overview. In this session we are going to discuss about a very special type of function which is called as recursion function. So let's start. Okay, so in C it is possible for the functions to call themselves. Okay, that means a function is called recursive if a statement within the body of a function calls the same function, sometimes also called as circular definition. Now recursion is thus the process of defining something in the terms of itself. Okay, let's now see a simple example of recursion. Suppose we want to calculate the factorial value of an integer. As we know, the factorial of a number is the product of all the integers between 1 and that number. Okay, for example, 4 factorial is equal to 4 into 3 into 2 into 1. Okay, now this can also be expressed as 4 factorial is equal to 4 into 3 factorial, where this exclamation stands for factorial. Okay, now thus factorial of a number can be expressed in the form of itself. Okay, as we can see from this expression. So this can be programmed using recursion. However, before we try to write a recursive function for calculating factorial, let us take a look at the non-recursive function for calculating the factorial value of an integer. Okay, so this is the function. We have to work through the program carefully till we understand the logic of this program properly. Okay, recursive factorial functions can be understood only if we are thorough with this implemented logic. So let's try to understand this function. Okay, basically in the main function we have the variable int a. So we have printed the message to enter the number and just read the number and store it into variable a. Okay, and we have passed the same variable to the function defined as factorial. Now in this function of factorial, it just copies the value of the variable and it runs a loop from the numbers to 1. Okay, and within the loop it just multiplies all the integers from the number and 1. Okay, as you can see, the factorial of a number is product of all the integers between 1 and that number. In the end, the factorial is stored into f and this f value is returned. Okay, so I hope this functionality is clear. You can see the output also, like if the number is entered 3, the factorial value will be for I equal to 3, which is greater than equal to 1, f equal to f multiplied by I. So by default f is 1. So 1 into 3. Okay, next time it is reduced to 2. So 3 into 2, 6. Next time it is reduced to 1. So 6 into 1 will be 6. Okay, now let's see the recursive function. Okay, so this is the recursive function. In the first run, when the number entered through scanf is 1, let us see what action does recursion take. Okay, now suppose this number that we have entered is 1. So the value of a, that is 1, is copied into x. That means the recursive function. Now since x turns out to be 1, so this condition that if x equal to 1, it's satisfied, and hence 1, which indeed is the value of 1 factorial, is returned through the return statement. Okay, that means if x is equal to 1, we have returned the 1 because factorial of 1 is 1. Now when the number entered through scanf is 2, then x equal to 1 test failed. Okay, so we reach the statement f into x multiplied by again the recursive of x minus 1. So we multiply x by recursive of x minus 1. Now since the current value of x is 2, it is same as saying that we must calculate the value of 2 into recursion of 1. Okay, now we know that the value of recursion 1 is 1. So the expression reduces to 2 into 1, or simply 2, which is the factorial of 2. Thus the statement x multiplied by recursion of x minus 1 evaluates to 2, which is stored in the variable f and is returned to main. Okay, where it is duly printed as factorial value equal to 2. Now perhaps you can understand what would happen if the value of a is 3, 4, 5 and so on. Okay, so this is the modified form of the previous code in which we have calculated the factorial. Okay, here what we have done is we have defined the function to calculate the factorial, and within the body of this function we have called this same function inside it. Okay, so this is a type of recursion function. Now let's understand the control flow, that how the control is flowing from the same function. Okay, so assume that the number entered by the user is 3. Okay, so now this figure shows that what exactly happens when the recursive function gets called. Okay, so let's start with 3. So from the main we have the value for this function call. So recursion integer x is equal to 3. Now it comes to the body of the function. So x is equal to 1. Okay, so this condition fails. Let's come to f equal to x multiplied by recursion of x minus 1. So from f equal to x multiplied by recursion of 3 minus 1, which is recursion of 2. So we have to see the value of this particular expression. So for that we have to again get back to this function call. So it just jumped to again the recursion function. So recursion int x. Now here x is equal to 2. Okay, again it comes to the body of the function and again this condition fails. because x is not equal to 1. Jumps to the else function, so f equal to x multiplied by again recursion of x minus 1. Here it is 2 minus 1, which is 1. But again the function is called recursion of int x, and here x equal to 1. So if x equal to 1, it returns true. Therefore here return statement is taken from 1. Okay, so f is equal to x into 1. Okay, from here it gets the value f multiplied by x into 1, and for this function x the value will be 2. So return f, so it will be written here 2. So f will be 3 multiplied by 2. Okay, and at the end we have f having the value 6. So return f will give the value to main function, which is the final value of factorial of 3, which is 6. Okay, I hope the concept is clear. Basically we are doing the same functions call again and again depending upon this conditions. Okay, so if we are starting with any number, so it just keep on reducing till this condition is satisfied, that is x equal to 1. Okay, so when it satisfies, the recursion stops, and finally we have the output as a factorial. Okay, similarly we have the types of function call, that is call by value and call by reference. We'll discuss with the introduction of pointers in the next session. Okay, but for now just pay attention to recursion and stack. Now there are different ways in which data can be organized. Okay, for example, if you are to store 5 numbers, then we can store them in 5 different variables: array, a linked list, a binary tree, etc. Okay, now all these different ways of organizing the data are known as data structures. Okay, the compiler uses one such data structure called stack for implementing normal as well as recursive functions call. Okay, now a stack is a last in first out data structure. This means that the last item to get stored on the stack, often called push operation, is the first one to get out of it, often called as pop operation. Okay, we can compare this to the stack of towels or the stack of plates in a cafeteria. Now the last plate that goes on the stack, that means the topmost plate, will be the first one to get out of it. Okay, so basically these are the example of stack. So now let us see how the stack works in case of a above program. Okay, so let's consider this program. We have a main function in which we have value of a and b as 5 and 2, and in C we have function for add in which the 2 parameters are passed, and at the end we are returning the sum of the 2 numbers. Okay, so let's understand how this stack works in this example. As you can see from the figure, at the beginning there is empty stack. Okay, so in this program, before transferring the execution control to the function fun, the values of the parameter a and b are pushed onto the stack. Okay, so value of a and b has been pushed onto the stack. Following this, the address of the statement printf. Okay, because right now printf cannot be performed because we don't have the values from the functions. Okay, so for now the address of this printf has been stored on the stack. It is necessary to post this address on the stack. In function, the values of a and b that were pushed on the stack are referred as I and j. Okay, so the local variable sum gets pushed onto the stack. So basically I and j copies the value of a and b and push to the stack with the address, and at the end the sum is also pushed onto the stack. Okay, now when the value of sum is returned, sum is popped up from the stack. Okay, that means when sum is calculated, it is returned to the main function, so it is removed from the stack. Next, the address of the statement where the control should be returned is popped up from the stack. That means at what address we have to go after returning the sum. Okay, that means we have to go to the main function, that means the printf. So popped up from the stack. Now using this address, the control returns to the printf function, and before execution of printf, the 2 integers that were earlier pushed onto the stacks are now popped off. Okay, so now a and b which were added on the stack. So after returning the control from the function, the printf statement executed and all the data has been popped up from the stack, and at the end stack become empty once again. So if this flow is clear, now let's try to implement the recursion function that we have discussed for calculating the factorial using the code block. Okay, let's jump to the code block window, click on new empty file, save this file to function folders. Okay, rename it as recfunction.c and click on save. Add comments like demonstration of recursion function, including the standard input output.h header file. Start the main function. Define a variable like int a and fact. Okay. Next thing is we have to printf. Enter a number. We need to store the value scanf %d comma ampersand a. Okay. So we have stored the value. Now next thing is fact is equal to rec. That means calling the function and passing the parameter value as a. Okay. And at the end we have to printf the result as factorial value is equal to %d and here passing the value of fact. Okay. Now let's define the function which is int rec. It takes the parameter as int x. Okay. Now start the body of this function. Define a variable int f which is equal to 1. Let's say. Okay. If equal to 1, then we have to return 1. Okay. But if x is not equal to 1, then we have to write f equal to x multiplied by recursion of x minus 1. So at the end we have to return the value of f. Okay. That means the factorial. Okay. So let's try to build the code. Okay. As you can see, there is no any errors. Now just click on run. Okay. So you can see the message, enter a number. Let's say I'm entering 4. So the factorial value is 24. That means 4 into 3 into 2. So 4 3 is a 12, 12 2 is a 24. Okay. So this is the factorial. Okay. Let's try running again. Let's check the factorial of 10. Okay. This is the factorial value of 10, which is 3628800. That means 10 into 9 into 8 into 7 into 6 into 5 into 4 into 3 into 2 gives you this value. Okay. That's all for this session. If you find any difficulties, feel free to reach us. Okay. So see you in the next session. Hello and welcome back to this course. In this session, we are going to discuss about pointers in C. In the previous session, we have discussed about overview of functions, that how we can declare, define and call a function in a C program. Now basically there are two types of functions called. That means a function can be called in two ways. Very first is call by value and second is call by reference. Now what's the difference? Whenever we called a function and pass something to it, we have always passed the values of variable to the called function, and such function calls are called calls by value. Example of call by value are shown below. Like in sum we have used calsum, within parameter we have passed a, b and c. Okay. Next is call by reference. We have learned that variables are stored somewhere in memory. So instead of passing the value of a variable, if we pass the location number, that is called as address of the variable to a function, then it would become a call by reference. Now this feature of C function needs at least an elementary knowledge of a concept called pointers. Okay. So basically pointers is a variable that points to a specific location. Let's understand using the pointer notation. Okay. Consider the declaration int I equal to 3. Okay. Now this declaration tells the C compiler to reserve space in memory to hold the integer value. Next, associate the name I with this memory location and store the value 3 at this location. Okay. If you see this figure, here I is the location name, 3 is the value that is stored at that location, and 65524 is the location number. Okay. So the variable that will store this location number, that is 65524, is called as pointer variable. Similarly, we can use pointer to function, pointer to array, pointer to structures and so on. Basically that will point to the address where that particular function, array, structure or a simple variable will be stored. Okay. Let's understand with an example. This is the main function. We have declared same int I equal to 3 and we have printed some parameters like address and values. So the expression ampersand I returns the address of the variable I, which in this case happened to be 65524. Remember, this address is just imaginary. Okay, it's not fixed. If you run this code in the code block, you'll find some other address. So if you see in the first printf statement, %i, okay, so this will returns the address of the variable I, and since 65524 represents an address, okay, there is no question of a sign being associated with it, okay, hence it is printed out using %u, which is a format specifier for printing an unsigned integer, okay, because address cannot be in negative sign. Next, the other pointer operators available in C is star, or you can say asterisk, that is called as value at address, okay. Now it gives the value stored at a particular address. The value at address operator is also called as indirection operator. Note that printing the value of pointer %i is same as printing the value of I. Now the expression %i gives the address of the variable I, and this address can be collected in a variable by saying j equal to %i. Now remember that j is not an ordinary variable like any other integer variable. So it is a variable that contains the address of other variable. Since j is a variable, the compiler must provide its space in the memory, okay. So as int I has allocated a space in the memory, similarly j is also a variable. It will also have a location in memory. So out of this discussion, the two important things we need to memorize is address of operator and value at address operator. Now as we have seen, i's value is 3 and j's value is i's address. But wait, we can't use j in a program without declaring it, okay? And since j is a variable that contains the address of I, so it is declared as int pointer j, okay? Now this declaration tells the compiler that j will be used to store the address of an integer value. In other words, j points to an integer, okay? So how do we justify the uses of pointer in the declaration? Int pointer j. So let's go by the meaning of pointers. It stands for value at address. Thus int pointer j would mean the value at the address contained in j is an int, okay? So basically this is the declaration of pointer variable. Let's understand using one more example. Here again we have defined int I equal to 3, and next we have defined a pointer variable j. So int asterisk j, and here j is having the address of I, okay? So we have printed the address of I using %i, address of I using j, address of j using %j. Similarly, we have printed the value of j, value of I, and we have printed the value of I using value at address notation, and the parameter is given as j or %i, which is one and the same thing. So if you see the output, address of I will be 65524, okay, that is %i. J is also equal to same thing because it is equal to %i, and %j, it is the address where j is stored, okay. Now again value of j, value of I, so all of them are printed. So for now we are done with pointer declaration, that how we can declare a pointer. Let's say int I equal to 3, this is a normal variable, but int pointer j or double pointer k. Similarly we can use multiple level of pointers, okay. Next is pointers definition, so we can define the pointers variable with a value. Pointers application, so basically it is used to pointing to an address, and that can be of address of variable, address of a function, array, structures, anything. Pointers arithmetic. Pointers variables can be incremented or decremented, added or subtracted by a fixed number. But there is slight difference in the operation of pointers arithmetic, okay. Like if we increment or decrement a pointer by 1, the pointer will start pointing to the immediate next or previous location, okay. This is somewhat different from the general arithmetic, since the value of the pointer will get increased by the size of the data type to which the pointer is pointing, okay. For example, int pointer j, okay. Now if j has address 65524, then j plus plus will be 65528, okay, because integer has 4 byte size. Similarly, j minus minus will be 65520 because integer has by default 4 byte size, as we are using compiler of 64-bit. If the compiler is 32-bit, then integer would have 2 byte. Okay. Similarly, we can add or subtract a value to the pointer variable as shown in the example. Okay. So again, int pointer j, and j has address 65524. So considering the compiler is of 64-bit, j plus 3 will be equal to 65524 plus 4 multiplied by 3. Okay, that means 12 will be added to this address. Okay, 3 times the size of int. Similarly, j minus 5, it will be 65524 minus 4 times 5. That means 65504. Okay, we have to keep in mind that default size of integer data type is depending upon the compiler. Now let's see the call by value and call by reference. So this is the example code for call by value and call by reference. In call by value, we have a main function and 2 variables having a equal to 10, b equal to 20, and we have a function called swap v. Okay, and we have passed the values a comma b, and at the end we have printed the value of a and b, and in the function swap v we have swapped the formal parameters and printed the result. Okay, same thing we have done in call by reference, but here we have swapped using the reference. Okay, that means address of the variable. So as you can see in the swap r function, there is a pointer variable definition, and we have passed the address of the variable, that is ampersand a ampersand b. Okay, and at the end we have printed the output. So in the call by value, output a and b will remain unchanged, because as we had already discussed in the previous session, that if there is any change in the formal parameters, then that will not be reflected in the actual parameters. Whereas in call by reference, the output of a and b will be changed because operation is taking place at the address. Okay, now let's check the output in the code block window. Okay, so let's jump to the code block window, create a new empty file, save this file in the functions folder, give the name as callbyvalue.c. Add the comments call by value, start by including standard input output.h, start the main function, define the variable a equal to 10, b equal to 20. Okay, next we have swap v function, in which we have passed a comma b, and we have printed the value of a equal to %d, b equal to %d, passed the value of a comma b. Okay, now let's define the function swap v. Okay, so it will take 2 parameters, let's say int x, int y. Within the function, let's take an intermediate variable, t is equal to x, x is equal to y, and y is equal to t. Okay, so we have swapped the values, and let's print the final output. Okay, so we can write %n/n for new line to %d, y equal to %d. We can pass x comma y as a parameter. Now let's build the code. We have 0 errors but 1 warning, so we can ignore this. Now click on run, and you can see the output that x and y, the values has been swapped. So x is 20 and y is 10, but the actual parameter, which is a and b, having the same value as defined in the starting. Okay, that means the swap functions perform the swapping with the formal parameters only. The change is not reflected in the actual parameters. Okay, now let's try the same thing using pointers. Again, create a new empty file, save the file as call by reference.c. Okay, and click save. You can add comment call by reference, start by #include stdio.h, start the main function, define the same variable, so int a equal to 10 comma b equal to 20. Next, we have called swap r function, in which we have passed the address of a and address of b. Okay, and at the end we have printed the output as /n for new line, a equal to %d, b equal to %d, and we have passed a comma b to the output. Now let's define the swap r function. Here it will take pointer variable, so int pointer x, int pointer y. Okay, we'll define intermediate variable, say int t. Here t is equal to value at the address of x. Similarly, value at the address of x will be equal to value at the address of y, and value at the address of y is equal to t. Okay, so we have swapped the values. Now let's try to build the code. Again, we have one warning, so not to worry, just click on run. As you can see the output, that means we have defined a equal to 10 and b equal to 20, but here the output is swapped. That means a equal to 20, b equal to 10. This is done using the pointers. Okay, that means whatever swapping is done, it is done at the address. That's why the output get swapped. So I hope now you have the basic concept of pointers, that how we can use pointers and what is the use of it. If you have any doubt, feel free to reach us. Okay, so that's all for this session. See you in the next one. Hello and welcome to this course. In this session we are going to discuss about a new data type, that is array. So let's start. Now what is array? Array is basically a kind of data structures that can store a fixed size sequential collection of elements that is of same type. Here is an example. Now let's talk about array declaration. To begin with, like other variables, an array needs to be declared so that the compiler will know what kind of an array and how large an array we want. So in our program, we have done this with the statement int marks 30. Okay. Now this 30 is the size. That means it will be going to store 30 values of marks. Okay. Next is accessing array elements. Okay. Now once an array is declared, let us see how individual elements in the array can be referred. Now this is done with a subscript, the number in the brackets starting from 0 following the array name. Okay. Now this number specifies the element's position in the array. Okay. So if you see the second for loop, that is for I is equal to 0, I less than equal to 29 and I plus plus. We have sum equal to sum plus marks, and within bracket there is a value written I. Okay. Now this is from 0 to 29, which is the index value for array. So basically marks of I will point each element starting from 0 to 29 that will be stored in this array of marks. Okay. Now entering data into an array. Now in order to enter the data into array, the array name with index is used as simple assignment. Okay. You can see here example, like if you want to store 67 in fourth index, then we'll write marks within bracket 3 equal to 67, and this index 3 denote the fourth element. Okay, because the index is starting from 0. Okay. Similarly, we can read the data from array. Okay. So in order to read the data from array, the array name with index is used and we can store it to a variable. Okay. Like example, value is equal to marks of 3. Basically, this program is used to demonstrate how we can store the data into array and how we can access the array elements. Okay. So you will see the first for loop, that is for I equal to 0, less than equal to 29 and I plus plus. So we have printf the enter marks and we are storing the value in the array declared for marks. Okay. In the second for loop, the elements of the array is accessed and added to this variable sum. Okay. And finally we have calculated the average, which is sum divided by the total number of elements, that is 30. So this is the basic code to demonstrate the array declaration, accessing array element, entering data into an array, as well as reading data from an array. Now let's talk about some more related to arrays. Array initialization. Now following are a few examples that demonstrate how to initialize an array while declaring it. Okay. So in the previous slide, we just see int marks with size. Okay. So we have not assigned any value to that, but we can do so during the declaration. You can see here like int num having size 6 and having these values like 2, 4, 12, 5, 45, 5. Okay. So these are 6 values that will be stored in this array of num. You can just assign all the values within curly brackets separated by comma. Similarly, it is not necessary to mention the size of the array. You can just keep it blank also, like int n, simple square bracket without any size. You can pass as many elements as you want and it will automatically denote that much size. Okay. Similarly, you can declare array for different data types, like here we have declared for int as well as float. Note the following points carefully. Till the array elements are not given any specific value, they are supposed to contain garbage value. Okay. So the very first thing, like if we have declared only the array and we have not defined the elements, then it will be having a garbage value. Okay. Now if the array is initialized where it is declared, mentioning the dimension of the array is option as in the second example above. As already discussed, like mentioning the size of the array is optional. Okay. Next thing is array elements in memory. So whenever we declare an array with size, that required bytes immediately get reserved in memory as shown here in the tabular method. Like suppose we have defined int array of size 8, then let's suppose this is the starting address for this array and their corresponding 8 bytes of memory will be reserved for this particular array. Next is very important thing, which is bonds checking. Now in C, there is no check to see if the subscript used for an array exceeds the size of array. So the data entered with a subscript exceeding the array size will simply be placed in memory outside the array. So probably on top of other data or on the program itself. Let's take an example. We have a main function and we have declared an array of size 40, that is int num of 40. Now what we are doing is we are assigning the values for I equal to 0, I less than equal to 100, I plus plus, num of I equal to I. If you will see here, the size is defined here 40. From 0 to 39, it will store the value of I. But after that, it will start storing the data outside this memory, okay? Or on top of other data. So might be other memory data will be corrupted. So we are responsible to see that the array should not go beyond its size, okay? So it is entirely the programmer's botheration and not the compiler, okay? Because compiler will not going to check whether this array is going out of the memory or not. Now let's talk about array to function, that how we can pass array to functions. Array elements can be passed to a function by calling the function by value or simply by reference. If you remember the example of call by reference and call by value, we have defined a swap function, right? So similarly, these are the examples that demonstrate passing array to a function, okay? So here is a function display in both the cases. And we have defined an array of marks with values like 55, 65, 75, 56, 78, 78, 90. In order to display these values, we can simply pass elements of the array one by one, okay? So this is the example of call by value, okay? So in call by value, we are passing an individual array element at a time to the function display and getting it printed in the function display. The element is collected in an ordinary integer variable m in the function display, okay? That means this is an ordinary variable, integer type m. M will copy the elements for each index and just simply print that. But in call by reference, we are passing address of individual array. So here you can see we are calling the function display. So as we are using address of operators, so simply we are passing the address. And since in the display function there is a pointer variable, so it just receives the address and print the value present at that address, okay? In call by reference, we are passing address of individual array elements to the function display. Hence the variable in which this address is collected is declared as pointer variable, as you can see from here. Now let's talk about pointers and array, how these things are related, okay? Now when we declare an array, then it points to the starting address of that array and the successive elements of the array is placed according to the address and size. Suppose we have an array num having the value 24, 34, 12, 44, 56, 17, okay? In the memory, it will be located as shown below, okay? Let's suppose the starting address of this array is 65512. Since it is of integer type, so each memory location will be of 2 byte and placed according to address and size. So you will note that the array elements are stored in contiguous memory and each element occupying 2 byte since it is an integer array. Now if we write a program to read the address as well as elements of this array, it will be as shown in the example. So we have defined the array, that is int num having these values, and we have just defined a for loop which is running from 0 to 5. We are printing the address as well as value of elements. So this method of accessing array elements by using subscripted variable is already known to us. Now this method has in fact been given here for easy comparison with the next method, which access the array element using pointers. So in the next slide, we'll see how we can use pointers to access the elements. So here is the example. We have the same array. We have defined a variable I and a pointer variable j, where j is having the address of the 0th index of this array. So in this program, we have collected the base address of the array, that is the address of 0th element, using the statement j ampersand num of 0. Now when we are inside the loop for the first time, so j contains the address 65512. If you remember the previous location memory map, 65512 is the 0th index. When we entered in this loop, the j will having the first index address, okay, and the value at this address is 24, okay. So these are printed using the statement. So we have just printf the address that is stored in j, and we have printed the elements by value at address operator. So pointer j will just print the value at that particular address, and after that we are incrementing j. So on incrementing j, it points to the next memory location of its type, that is location number 65514, okay. But location number 65514 contains the second elements of the array. Therefore, when the printf statements are executed for the second time, they print second element of the array and its address, okay, that is 34 and 65514. So you can see the output of this program would be address equal to the corresponding address and element equal to the elements at this particular address. Now accessing array elements by pointer is always faster than accessing them by subscript method, okay. So if you really want to speed up your code, you can use pointers, okay. So that's all for this session. In the next session, we'll just implement these example codes one by one. So if you feel any doubt related to array, feel free to reach us, okay. So see you in the next. Hello and welcome back to this course. In the previous session, we have discussed about the introduction of array, okay. Now in this session, we are going to implement the codes that we have discussed as an example over array, okay. So let's start. So very first, just go to new file, create empty file, and just save this file. You can just create a new folder and let's give it a name as array. Now just open up this folder and within this example1.c. Now click on save. Now let's try to implement the very first code that demonstrate the declaration of array, accessing the array elements, as well as reading and writing to the array, okay. If you want, you can just add comments. Demonstration of array basics. So start by including the header file, which is stdio.h. Start the main function. Now let's define the variable int average comma sum, which is equal to 0, int I, int marks with size 30 semicolon, okay. So this is the declaration of array. Now let's define a for loop, which is I equal to 0, I less than equal to 29, I plus plus, okay. Start the curly brackets and just printf the message, enter marks, and we have to store the value. So scanf within double quotes the format specifier, which is %d, and marks of I. So this is the loop for storing the elements to the array. Now just create one more for loop. So for I equal to 0, semicolon, I less than equal to 29, semicolon, I plus plus. Start the curly brackets. Now here we will just store sum equal to sum plus marks of I. So here we are accessing the array elements. Next we need to calculate the average. So we can write AVG is equal to the total sum divided by 30, and at the end we can print the result /n, that is for new line, average marks is equal to %d, and we can just pass average value. So we are done with the code. Now just go to build. You will see the code compiled successfully. Now let's try to run this code. Okay, so here is the output. The message has been printed for enter marks. Okay, so we have to enter marks 30 times. So I'm entering some random marks. Just pay attention, never cross the value for 30, because once it is crossed to 30, average marks will be printed. Just keep it slow and you will see the average marks 50. So after entering, let's count these number of values: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 29 and this 30. Okay, so after 30 entries we have get the output which is average marks, okay, which is 50. So basically all these marks are added one by one and finally divided by 30. So I hope this example is clear. Now let's try the next one. So again go to new file, create an empty file and save this file to the same folder, and let's give the name as example2.c. Click on save. So you can add comments. Now we are going to implement the example that uses pointers to access the array element. Okay, so you can add comments accessing array elements using pointers. So include the header file which is stdio.h, start the main function. Now let's define the variable. Let's say int num equal to, within curly brackets the value should be added, so 24 comma 34 comma 12 comma 44 comma 56 comma 17, okay, semicolon. Okay, so we have created an array. Let's create another variable int I. Now let's create a pointer variable which is pointer j. And here j is equal to the address of num0. Okay, that means the 0th element of this array. So right now j is having the address of 0 element. So let's try to access the elements one by one. So for I is equal to 0, I less than equal to 5, I plus plus. Okay, now let's start the curly brackets. Printf within double quote /n address is equal to %u, which is for unsigned int, and comma j. Okay, so j is having the address of the element. Next we have to printf the value, so we can write elements is equal to %d, that is for int, and we can pass the value at address told by the pointer variable j. And at last we have to increment the address. So basically this is incrementing the address of the array elements. Now let's try to build the code. You will see the build finished with 0 errors and 0 warnings. Now let's run this code. Okay, so you will see here the value printed as address equal to 6356704 and elements is equal to 24. Okay, you can see the output is not clear because there is no any space between the address and the elements. Okay, so let's try to add this. So close this output window and you can just simply write /t, which is for tab. Let's build again and run the code. Okay, so now output is clear. You can see the address as well as elements printed in a single line. Here the address is 6356704, which is the base address, that is for 0th element. Okay, the next address is added by 4. So 04, 08, 12, 16, 20, 24. Now you will ask, in the example the address was incremented by 2, but here the address is incremented by 4. Okay, now this depends upon the compiler. Code block is using a 32-bit compiler. Okay, therefore the size of int is 4 byte. That's why the address is incremented by 4. Okay, I hope this thing is clear. So that's all for this implementation. You can implement other examples on your own, and if you find any difficulties, feel free to reach us. Okay, so see you in the next session. Hello and welcome back to this course. In this session we are going to discuss about multi-dimensional arrays. So far we have explored arrays with only one dimension. Now it is also possible for arrays to have 2 or more dimension. The 2-dimensional array is also called a matrix. Okay, so basically this is an example to demonstrate the declaration, storing the elements and accessing the elements of 2D array. Okay, so array declaration. Now to declare a 2-dimensional array, we need to add 2 subscript as shown in the program. Okay, so here you can see int stud for 2. Okay, so we have mentioned 2 size. The first subscript of the variable indicates row number and the second subscript of the variable indicates column number. So basically, if you remember, the matrix is basically a row and column representation of elements. These 2 values of size, that is 4 and 2, these are row and columns value. Next is array initialization. Now it is important to remember that while initializing a 2D array, it is necessary to mention the second dimension, that is column, whereas the first dimension row is optional. So thus the following statements are perfectly acceptable. So you can just simply assign the values like int stud 4, 2, that means 4 rows and 2 columns. So you can pass the value as 1 2 3 4 comma 5 6. That means row 1 value, this is for row 2, this is for row 3, and this is for row 4. Or simply you can just pass all the elements serially, okay, and it will automatically be added for row 1 column 1, row 1 column 2, row 2 column 1, row 2 column 2, and so on. Similarly, we can pass the array elements without mentioning the size of row. So as we have discussed here that column dimension is necessary but row is optional. Okay, so you can add int array with blank row and 3 column. Okay, so this is the initialization of array. Now this initialization will again have the memory map as shown here. The starting address is again 65508, and whatever value will be passed sequentially, that will be added to the next address. So you can see 65508 is having the 1 2 3 4 value, which is row 0 column 0. Similarly, for row 0 column 1 we have 56, which is stored in next corresponding address. Okay, this program that will be used to declaring 2D array and storing the value of roll number and marks, and finally printing them. Next is pointers and 2D array. The way we have discussed the pointers in one-dimensional array, similarly pointers can be applicable for two-dimensional array also. So each row of a two-dimensional array can be thought of as a one-dimensional array. Now this is very important fact, like if we wish to access array elements of a 2D array using pointers, thus int s 5 2, okay, so 5 rows 2 columns can be thought of as setting up an array of 5 elements, each of which is one-dimensional array of containing 2 integers. So basically you can imagine like 5 row and 2 column. Okay, so basically we have 5 rows, 1 2 3 4 5. So we can see like 5 elements are in an array having 2 integer value. So we can say that two-dimensional array is a one-dimensional array of 2 elements. Now we refer to an element of a one-dimensional array using a single subscript. Similarly, if we can imagine S to be a one-dimensional array, then we can refer to row 0 element as S0, the next row element as S1, and so on. Now more specifically, S0 gives the address of 0th one-dimensional array, S1 gives the address of first one-dimensional array, and so on. Now this fact can be demonstrated by the program shown here. Let's figure out how this program works. Now you will see here we have the array int s having 4 rows and 2 columns. So these are the values for row and column. For int I equal to 0 less than equal to 3i plus plus, we have printed the address of the array, that is one-dimensional array. So what we have done is we have simply called the address of one-dimensional array. So here is the output, like address for 0th one-dimensional array is 65508, for 1 it is 65512, for 2 65516, 3 65520. Now you will see here the address is incremented by 4. Why? Because at 65508 it is one-dimensional array having 2 elements, that is 1 2 3 4 and 5 6. So 1 2 3 4 is for row 1 column 1 and 56 is for row 1 column 2. Therefore 65508 is having 2 values, and after that 4 byte size is incremented for next one-dimensional array. The compiler knows that S is an array containing 4 one-dimensional array, each containing 2 integers. Okay. Now each one-dimensional array occupies 4 byte, that means 2 byte for each integer. Now these one-dimensional arrays are placed linearly, that is from 0th 1D array followed by first 1D array, etc. So here you can see again the same memory map. So each one-dimensional array start 4 bytes further along than the last one, as you can see in this memory map. Okay, so if you consider these group of 2 values as one-dimensional array, so 0th 1D array will be 1 2 3 4 and 5 6, these 2 values. Similarly, for the next 1D array will be 1 2 1 2 3 3, and next these 2 groups, and next these 2 groups. Okay, therefore the output in the previous program has 65508 for 0th 1D array, 65512 for first, second 65516, and third one-dimensional array 65520. If you are getting confused, just imagine like 1 2 3 4 5 6 is a single array. Okay, let's give it name as S0. Now S0 has 2 elements, okay, like 1 2 3 4 and 5 6. Similarly, S1 has 1212 and 33. Similarly, S2 has 143480, and at the end S3 has 131278. Okay, so basically there are four one-dimensional array having two elements. This is the representation in 2D matrix. Now we know that expression S0 and S1 would yield the address of 0th and first one-dimensional array respectively. Okay, so from the memory map shown, these addresses turn out to be 65508 and 65512. Why? Because 65510 has been considered in S0 array. Now suppose we want to refer to the element S21, that means row 3 column 1. S2 would give the address 65516, which is the address of the second one-dimensional array. The value at this address can be obtained by using value at address operator. Okay, that means pointer within bracket S of 2 plus 1. So we have already studied while learning one-dimensional array that num of I is same as value at address num plus I. Let's say if we are talking about num of 0, so the 0th element will be addressed. Okay, that means 1 2 3 4. Again, if we are calling num plus I value at address operator, so num will be the 0th address, that is 65508, and I will be stored, so I is 0, so 65508 plus 0 will correspond to this same address. Okay, so I hope this both expression is clear to you. Like num I, it's same as value at the address num plus I. So the following expression refer to the same element. Okay, let's say S of 2 1. What will happen? S of 2 means this address, that is 1434, and S of 2 comma 1 will be 80. Similarly, if we consider the second expression, S of 2 plus 1, that means value at address hold by S of 2. So you can see S of 2 is 65516. So 65516 plus 1, that means the next address will be 65518. Now the value at address of 65518, that is same 80. Similarly, the next expression, value at address S plus 2 1434. Now plus 1. So if we add value to plus 1, it will correspond to the next location, that is 65518, and again value at address 65518 will correspond to 80. So all these three expression will result in accessing the element 80. So I hope accessing the 2D array using pointers is clear to you. If you have any doubt, then we'll just clarify it in our implementation session. Now let's talk about array of pointers again in case of two-dimensional array. So the way there can be an array of ints or array of floats, similarly there can be array of pointers. Okay. Now since a pointer variable always contains an address, an array of pointer would be nothing but a collection of address. So the address presence in the array of pointers can be addresses of isolated variable or addresses of array elements or any other addresses. All rules that apply to an ordinary array apply to the array of pointers as well. I think a program would clarify this concept. So you can see this is the program in which we have the array of integer pointers. Okay. So we have int pointer array of size 4. Now here int I equal to 31, j is equal to 5, k equal to 19, l equal to 71, and we have a variable m. So you can see array of 0, 1, 2, 3 contains the address of I, j, k, l respectively. Now for m equal to 0 and m less than equal to 3, m plus plus, we have printed the value of array of m. That means we are printing the addresses of this array. So basically the output will be this array, that means the address of I, j, k, l that will be stored in this array ARR. Now you will see it contains the address of IJKL, that is 65516141210. Okay, you will see this address are decrementing. Okay, because while we are initializing the IJKL, these variables have taken a certain address. Okay, so it is not necessary that they occupy the sequence, but the array which is present here as a pointer array, it will be stored in sequence. Okay, so it start from 65518 and stored 20, 22, 24 in a sequence of 2 bytes. So I hope this thing is clear how array of pointers can be declared. Okay. And at last, let's take an overview of three-dimensional array. So basically, a three-dimensional array can be thought of as an array of arrays. So basically, it's nothing but a one-dimensional array, okay? And one-dimensional array will contain another array which further contain an arrays of elements. So the outer array has 3 elements, each of which is a two-dimensional array of 4 one-dimensional arrays, each of which contains 2 integers. Now it sounds really very confusing, so we'll see using a figure. Okay, by the time, just see the declaration, how we can declare the value for 3-dimensional array. Here you can say 4 and 2 are row and column, okay, but 3 you can understand as the depth, okay, or the pages. Okay, so here is the example. You can see here, this is page 1, this is page 2, this is page 3. Basically, this is a 3D array divided into 2D array, and as we have discussed that 2D array can be described as one-dimensional array having 2 elements in this case. Similarly, the 3-dimensional array can be considered as 3 2-dimensional arrays. This is 0th 2D array, this is first 2D array, and this is second 2D array. In other words, a one-dimensional array of 2 elements is constructed first. That means this page, you can consider that there is 1, 2, 3, 4 one-dimensional array having 2 elements. Then 4 such one-dimensional array are placed one below the other to give a 2-dimensional array containing 4 rows. So you can see 1, 2, 3, 4. So these 4 one-dimensional array has been kept below each other to give a 2-dimensional array containing 4 rows. Then 3 such 2-dimensional array, that is this page and beyond it. So 3 such 2-dimensional array are placed one behind the other to yield a 3-dimensional array. So I hope the concept is clear. If it is not clear, don't worry, it is used very rarely. The next session we are going to implement the example that will demonstrate the use case of these arrays. So that's all for this session. Hello and welcome back to this course. In the previous session we have discussed about the multi-dimensional arrays. Okay, so here we are going to implement some example codes to just demonstrate how this 2-dimensional array works. Okay, so again let's go to file, new, and create an empty file. Okay, just save the file within the same array folders that we have created. So you can just write here example3.c. okay, so just click on save. You can add comments like demonstration of 2-dimensional arrays. So start including the header file, that is stdio.h. Start the main function. Now let's define a 2-dimensional array. So int stud for 2. Okay, so this is declaration of 2D array. Now let's define other variables like int I comma j. For I equal to 0, I less than equal to 3, I plus plus. Start the curly brackets. Now here we can printf the message, enter the roll number and marks in a new line. Next things we need to store the value. So scanf. Within double quotes, we have to add %d for adding the 2 elements. So we can write ampersand array stud with row I and column 0. Similarly, the next element will be ampersand stud with row again I and column 1. At the end, semicolon. Now let's create another for loop to print the value. So I equal to 0, I less than equal to 3, I plus plus. We can use simply printf /n %d, comma array element which is I as row and 0 as column. Next element which is stud having row I and column 1. Okay, at the end semicolon. So let's try to build the code and you will see the build finished with 0 errors and 0 warnings. Now let's run the code. Okay, so here you can see the message for entering the roll number and marks. So let's write the roll number and marks. Okay, so roll number 21, marks is 65, roll number 22, marks is 86, roll number 23, marks is 69, and roll number 24, marks is 85. Okay, so you can see the data has been printed as 2D matrix. So 21, 65, 22, 86, 23, 69, 24, 85. So in this way, the 2D array can be declared and accessed. Okay. Now these two-dimensional arrays can be really very useful to perform the calculation related to matrix. Okay, like you can add two matrices, subtract them, find the product of two matrices, and even print the diagonal. Okay, you can try these examples on your own, and for now I am just showing you one example to print the diagonal of a two-dimensional array. Okay, so let's create another empty file and save this as example4.c and click on save. You can add comment displaying the diagonal elements of a two-dimensional array. Okay, so start with hash include stdio.h, start the main function. Let's define the variable int r, which stands for row, and it is equal to 3. Okay, similarly c, which stands for column, it is also equal to 3. Now define a matrix called mat having row equal to r and column equal to c. Int I comma j. Now we can printf the message in a new line into the elements of array. We can create a for loop. So for I is equal to 0, I less than equal to 2, I plus plus. Okay, so this will count the number of rows, and within this we can create another for loop which is j equal to 0, j less than equal to 2, j plus plus. Now within this loop you can printf the message like enter matrix element, and finally we can scanf the value by within double quote %d and storing the value in matrix array with row I and column j. So from here we have stored the values from the user. Now we have to print the diagonal. Okay, now in order to print the diagonal of this matrix, we have to print the elements where I and j, that is row and column values are equal. What you can do is you can copy this segment of code and paste here again. So within the body of second for loop, we have to compare, like if I is equal to j, then we have to printf %d with /t, that is for tab, comma mat I j. If it is not equal, like if I is not equal to j, we have to printf the space, or you can say the tab space. Okay, and after the execution of second loop, just we have to print /n and say this is for new line, this is for diagonal element. You can just simply remove this line. Okay, so we are done with the code. Now let's try to build this code. Okay, so you will see the build finished with 0 errors and 0 warnings. So now let's run this code. Here the message is displayed, that is enter the matrix element. Let's say I'm entering 15, next is 26, next is 21, 47, 12, 32, 36, 48, 41. You can see out of these elements only the diagonal element has been represented. Okay, so if you see the complete matrix, that is 15, then 26, then 21, then 47, then 12, then 32, 36, 48, 41. So out of these values only 15, 12 and 41 has been printed. So you can see how we can print the diagonal element. Okay, similarly you can perform other operation on matrix like transpose of matrix, addition, subtraction, finding the product of two matrices. So you can try this example on your own, and if you find any difficulties, feel free to reach us. Okay, so that's all for this session. See you in the next one. Hello and welcome back to this course. In this session we are going to discuss about strings in C. So let's start. Now the way a group of integers can be stored in an integer array, similarly a group of characters can be stored in a character array, and character array are mainly called as strings. Now you will see the character array or string are used by programming languages to manipulate text such as words and sentences. A string constant is a one-dimensional array of characters terminated by a null character, that is \0. Okay, you can see here char name having the elements as H, A, E, S, L, E, R, and at the end we have \0. So the memory map is shown here like an integer array. The characters has been stored at the sequence of addresses, and here the addresses is incremented by 1 byte because each character will occupy a single byte value. Now the terminating null is important because it is the only way the function that work with a string can know where the string ends. That means if \0 is not added, then the function will not know that the character array has been ended. So we would use string very often and hence provide a shortcut for initializing string. So for example, the string used above can also be initialized as char name equal to the string added within double quotes. Okay, and here we don't need to declare the \0. So you can see the program to demonstrate the printing of a string. So we have a char array and these characters are written in double quotes. So int I equal to 0. So while I is less than equal to 7, we are printing the elements of this character array one by one. And so here is the output. So it's nothing new. Everything is similar as one-dimensional array. The difference is that here the array is of characters. Now we can write the while loop without using the final value 7 because we know that each character array always ends with a \0. So for example, while name of I is not equal to \0. So we can use this while to just print all the values. Okay. This program does not rely on the length of the string. Okay, so we don't need to mention the length of the string to print out its content, and hence is definitely more general than the earlier one. So in the earlier code, we just compared that I is less than or equal to 7. Okay, but here we can just monitor the \0. Similarly, we can write the same code using pointers to access the array elements. So example is shown here in this code. So we have a char name having this name that is Klinsmann, and we have a pointer to character. Okay, what we have done is we have stored the address of this array to the pointer variable. Okay, so while value at the address defined by pointer variable is not equal to \0, we can print the value by pointers variable. Okay, so basically as with the integer array, by mentioning the name of the array we get the base address. Same is here also. Okay, so the base address is stored in the variable ptr, that is using this line ptr equal to name. So once the base address is obtained in ptr, so value address at ptr would yield the value at this address. Okay, so which gets printed promptly through printf %c. Now %c is the format specifier for character data type, and we have the operator pointer ptr. Okay, so this is the value address. So this process is carried out till ptr doesn't point to the last character in the string, that is \0. Okay, now in fact the character array elements can be accessed exactly in the same way as the element of an integer array. The printf function has got a sweet and simple way of printing the string as printf %s, name. Now here %s is the specifier for string data type and the name is the character array or simply string. Now we have the library functions for this string. Okay, so with every C compiler, a large set of useful string handling library functions are provided. So here are the list of the more commonly used functions along with their purpose. Okay, so out of these list, the function like strlen, strcpy, strcat, strcmp, these are the most commonly used function. Okay, so let's discuss one by one. strlen, what is this function? It finds the length of a string. strlwr, so it's convert a string to lowercase. Okay, similarly strupper, that means convert a string to uppercase. String cat, so it appends one string at the end of another. Okay, strncat, now append first n characters of a string at the end of another, so we can monitor the number of characters that need to be added. Okay, similarly there is string copy, that means copy a string into another. String n copy, that means copy first n characters of one string into another. String cmp, it compares the two strings whether the strings are equal or not. So again the strn compare, it compares the first n characters of two string. Next is string cmpi. Now I stands for ignoring the case. Okay, so the comparison of two string will be done without regard to case. Similarly, strnicmp, that means comparing the first n characters of two string ignoring the case. Next is we have the function strdup, that is for duplicating a string. strchr, so basically it finds the first occurrence of a given character in a string. Let's say if you want to search E in hello, then this function will returns you the index number of E. Similarly, string rchr, so find last occurrence of a given characters in a string. str, so find the first occurrence of a given string in another string. So we can find a piece of string that is subset of a main string. String set, though sets all characters of string to a given character. strn set, it set first n character of a string to a given character, and strrev, so it just reverse the string. So string functions allow two functions alternate to printf and scanf, that is putS and getS. Though scanf can be used to receive multi-word strings, but getS can do the same job in a cleaner way. Now both printf and putS can handle multi-word string. That's all for the overview of string. Now let's see an example how to declare a character array, or simply how to declare a string and print as the output. So let's jump to the code block window, create a new file and save this file. Okay, so here just create a new folder for string. Now open this folder and type example1.c. You can add comments, demonstration of string declaration and printing. Okay, so start by including the header file is stdio.h. Start the main function. Let's define the character array char name is equal to, within double quotes, Klinsmann semicolon. We have to define another variable int I equal to 0, while the name of I, that means the element of character array name, is not equal to \0. After starting the curly brackets, we can just printf the elements. Next thing is we need to increment the I and close the brackets. Okay, now build this code. You will see there is no any errors. Let's run this code. Okay, so you can see the output here. Klinsmann is printed here. So in this way we can declare a string and access the elements of that particular string. Okay, and welcome back to this course. In the previous session we have just implemented a basic code that how we can declare a string and access the elements. Now in this session we are going to implement few functions of string library. Okay, so let's start. Now create a new empty file and just save this file within the string folder. We have example1 already, so you can just write as example2.c. Now here you can add comments like demonstration of strlen function. Now you can start by including the header file stdio.h. You can start the main function. Now let's define a character array str, which is equal to hex and bit. Okay, now you can simply printf length of string is %d and comma, we can just call the function strlen, and within bracket we can pass the parameter string semicolon. Okay, now let's try to build this code. So we have one warning, that is implicit declaration of built-in function, that is strlen. Now this strlen is a function of a string library. Okay, so you have to include string.h. Okay, let's build again and you will see there is no any errors. Okay, now just try to run this code. Okay, so you will see here the length of the string is 9. Okay, like if you count this hex and bit, it is 1 2 3 4 5 6 7 8 9. Total 9 characters are there including the spaces. Okay, so the length of string is 9, so it is returned by this strlen function. So I hope this function is clear. Now let's try to use string compare function. Okay, so close this window, create another empty file and save this file as example3.c. You can add comments, demonstration of string comparison function, that is strcmp. So start including the header file that are required, so stdio.h, and next thing is hash include string.h. Now start the main function. Now let's define two character array or string like s1 hexen bit and another string s2 which is equal to x and bit.com. Now we need to compare two character array or string if strcmp within bracket we can pass s1 comma s2. That means we are comparing the string 1 and string 2. Now if these are equal, then this function will return 0. Okay, so if string comparison returns 0, we have to print like string s1 and s2 are equal. And if it is not, then we have to printf string s1 and s2 are not equal. Now let's build the code. So again, no errors. Now let's run this code. Okay, so you can see that string s1 and s2 are not equal because hexenbit and hexenbit.com are not the same string. Okay, now let's try to make this string same. Close this window and just delete this .com from here. Now let's build the code again and run the code. You will see the output string s1 and s2 are equal. So in this way, the string comparison function, that is strcmp, can be used to test the two string whether they are equal or not. Now let's try to use another function. So create new empty file again. Save this file as example4.c. Now you can add comments. Demonstration of string cat function. Okay, that is strcat. Now include the required header files. Start the main function. Now again define toString char s1 which is equal to hello. There is a space after hello. Next another string char s2. Let's define world semicolon. Now we can call the function string cat and pass the toString as parameter. So s1 comma s2. Now printf output string is %sn which is s1. Now why I am adding s1 here? Because after adding these two string hello world, the complete string will be stored in s1 itself. That means in s1 s2 string is added. So let's see the output. Just build this code and run. So you will see the output string is hello world. The two has been added in a single string. Let's implement other function. Just go to new and create empty file again. Save the file as example5.c and click on save. You can add comments. Demonstration of string copy function. Okay, so again include the header files that are required at the main function. Now let's define the toString char s1 having size 30 which is equal to in 1 colon. So this is the string 1 s1. Let's define char s2 of size 30 again, and within this let's define string 2 colon I am just busy full stop. Okay, so these are the two string s1 and s2. Now we need to copy s2 into s1. So we can write string copy s1 comma s2. Like previous function, the s2 will be copied into s1 and the final string will be stored in s1 itself. If you printf s1, you will see the output. So output is %s. We are passing s1 as the value. So let's try to build the code. There is no any errors. So click on run. So you will see the output which is string 2. I am just busy. Okay. Now you will see that we have printed s1, but the content is printed from s2. Why? Because this complete string of s2 has been copied to s1. So in this way we can use string copy function. Okay, now let's try one more. Create an empty file. Save the code as example6.c. Okay, you can add comment demonstration of str reverse function. So include the required header files, that is stdio.h include string.h. Now start the main function, that is void main. Start the curly brackets. Now define a string, let's say s1 which is equal to hexenbit, just semicolon. Now we are printing the reverse of string. Okay, so we can write reverse of s1 is %s, and we can just call the reverse function, that is strrev, and pass the string which is s1 and semicolon. Now just build this code and you will see there is no any errors. Now click on run. Okay, so you can see here the output. So hexenbit has been written in reverse order. Okay, that is TIBNXEH. So hexenbit has been reversed. So that's all for this session. I hope it is clear that how we can use the function of strings. Similarly, you can try other functions, and if you find any difficulties, feel free to reach us. So see you in the next session.